Okay. Hey, Roshana, all good? Um, awesome. So, hey guys. Yeah, Fernando, you're up after some. Yeah, hey guys. Thanks so much for tuning back into our AI Day Summit 2025. That was just an incredible talk from Bhavani and Arjun from our TRVR. They shared the QR code. We'll put the link in the Slack channel too for you to check it out. Next up, we have a really special speaker, someone who I called a dear friend as well. Sam, it's nice to see you.
Hey there.
So Sam is the founder of a company called RoboApply, and yeah, kind of has experience as a data scientist from CVS Health. One of the best engineers I know, and is someone that I'm really excited to see what he builds either here or next.
Awesome. Yeah, I mean, thanks so much, Nathan and Nathan. And to be honest, the last demo was absolutely incredible, and I think everyone should give those guys a round of applause. I really loved seeing agentic web tech on Chrome extensions. And I guess I can just share my screen and show you a little bit about the platform that I built called RoboApply. And it's a purpose-driven platform specifically for applying to jobs with agents. And so the page you're seeing right now is our homepage, and the idea is right, like you can upload a resume and start a campaign. And basically, what will happen in the back end is we'll have like an agent go and start applying to different jobs for you. And then we are in the mix actually of making our own extension, which I can preview right now a little bit on a test account on LinkedIn. So, sec. Oh, shoot. Okay. Well, it looks like I might have corrupted my own extension here by pulling in a different repo. But yeah, we're coming out with an extension, and it's going to have the same capabilities as some of the stuff that you saw in the last demo. So the idea would be that like we'll run an agent against like these different platforms: LinkedIn, Indeed, Monster, and Glassdoor. Right now, we're running everything deterministically using just like the DOM, etc. But then, in the future, it will all like run via an agent. And then other cool stuff about the platform is we have less sort of like agentic stuff and more just like data aggregation. We aggregate all of different job platforms, so you can like look across like a data scientist across multiple platforms for free. For example, this is looking at Indeed, LinkedIn, Google Jobs, Glassdoor, ZipRecruiter. So there's a lot of like cool features to the platform, not just like with the agentic applying, but also just like Chrome extension. And then we have another tab that does resumes. So the project itself has been kind of like like just adding a lot to it every day, and trying to basically make sure that we're staying up with the trends. So yeah, I mean, the platform right now is in a sort of flux state. As you can see, the Chrome extension and stuff it wasn't functional just now, and part of that is because I pulled the wrong repo branch just before this demo because I thought I was gonna be fancy and show you like some sort of agentic update. However, definitely look out for more stuff from us in the future. I think that there's a place in my heart for pure agentic, like agent web browsing, as well as like injecting deterministic web browsing. Um, so yeah, I think the last startup that was on kind of like exemplified sort of the ethos that I have in terms of I think agentic browsing via Chrome extension is the way to go, and RoboApply will be sort of subsuming that sort of technology. Um, so yeah, that's all for me for now, and hopefully in the next couple of weeks, you guys will see maybe an update from Nathan about the platform. Was I sharing my screen that whole time?
Yeah, that's correct. It was good. Yeah, you were sharing your screen. Yeah, I guess for anyone who doesn't know, just the general kind of idea behind RoboApply is you essentially can use these AI agents, or in the future AI agents, maybe now like some web scraping, to kind of find a bunch of these jobs and then like automatically apply to them. And then you can also do like a lot of incredible features like customizing your resume, as well as a lot of things to kind of automate a really tedious process. So kudos to Sam for building this. Anything else like that?
Yeah, all I can say at this point is like I've been extremely busy with some other agent work around like financial agents for my full-time job. So it's been like really sort of like a hectic thing. But I can also there's one platform that I've been kind of toying with, which is this platform called Memorial, where I'll be kind of making agents out of URLs. And so, I mean, if you want, I could show that.
Yeah, I think now we're at time, so that's good. But maybe
Okay, yeah,
share it in our Slack
yep,
channel. And
yeah, I'll share in the Slack channel.
appreciate your time, Sam. Appreciate you.
Yep.
Hey, Natan, can you hear me?
It's amazing talk by Sam. You know, honestly, RoboPod is a really cool product. If you're kind of in the job search process, I definitely recommend checking it out. They're making recurring revenue now, and it's actually really functional, can help a lot of people. So I'm excited to hopefully see this come to fruition, and or whatever Sam builds next in the AI agent space would be amazing. Next up, a product I personally use today, almost every day since I've learned about it 3 weeks ago, is Narada. This is, in my opinion, one of the best AI products out there. I'll let Fernando introduce himself and kind of give you a quick demo of the platform.
Yeah, awesome. Thanks, Natan. Appreciate it. You can hear me, right? Okay, fantastic. Well, I have a little slide deck to show as well, but we can go into a live demo. But my name is Fernando. I'm the head of growth here at Narada. We're an early stage startup that's still coming out of stealth, based in UC Berkeley, coming out of the UC Berkeley AI labs. And we are building and have built agentic process automation, or computer use for the enterprise. If the chat could offer some feedback on the different vocabulary that they have heard when it comes to agentic AI. Have they heard agentic process automation or computer use for the enterprise? Which one have you heard? That would be fantastic, as I'm still doing some A/B testing on what are the masses using these days. So let me go ahead and share my screen. If you can dive into the deck. Awesome. Okay. Well, Natan, if you can confirm that you can see my screen, that would be great. There we go. Perfect. Okay. So like I mentioned, we built computer use specifically for the enterprise. So a lot of you have probably heard operator from OpenAI, or computer use from enterprise, or excuse me, from Anthropic, and some of their demos that really dive into consumer tools, like DoorDash, OpenTable, servicing different consumer services that they are building for the billions of masses, right? Our approach is a little bit different. We are building specifically for the enterprise, where we can really dive into building our large action model specific to traditional B2B SaaS tools like ServiceNow, Oracle, SAP Concur, Gmail, Calendar, and really build specific models per tool, so that we have a lot of high reliability success and reliability for when we do operate workflows across multiple different tools. So without further ado, our MO is specific, right? AI needs to grow up and get a job. While everybody was building LLMs for the foundational models, creating chats and essays, we thought that was fantastic. But the capabilities that AI actually have go way beyond that. So that's where we come into play with agentic automation, where it can orchestrate different workflows in IT, HR, operations, for individuals in enterprises to make them more productive, right? And actually deploy AI to be productive for individuals to increase revenue per employee, as well as overall productivity. So our solution is that we have this orchestration layer and specific models built for each tool like email, ServiceNow, Oracle, where you could just communicate with Narada through a Chrome extension with natural language or real-time API, which I'll demo in a second. And then our model, right, will orchestrate the different task at hand, break down each task across multiple different tools that operate your browser through API calls, or web browser automation if APIs aren't robust enough. And like I mentioned, this is based on new research coming out of UC Berkeley, where we can orchestrate different and execute different tasks across your browsers and different tools in the enterprise. We were a top 20 finalists at TechCrunch Startup Battlefield. And how we deploy this is very simple, right? It's just a side pane that lives in your browser and takes context of what's happening in your left-hand screen. And like I mentioned, the large action models are specifically designed for each enterprise level tool, so it can adapt it to different user interfaces based on the tool, right? Your Salesforce might look different than someone else's Salesforce, or ServiceNow might look different than someone else's ServiceNow. Our models, it doesn't really matter what your user interface looks like. If we have a generic model built for that tool, it'll adapt and learn what buttons need to be clicked on, or what segments need to be filled out. So there's no configuration, there's no scripting like role-based automation, and it works right out of the box. From a security perspective, we're SOC 2 compliant, GDPR, CASA level 2, and CCPA as well. And to give you guys a little bit of a under the hood look at this, Narada goes ahead. We have an orchestration layer called the LLM compiler, where it will orchestrate different tools for an entire workflow. And then, like I said, the specific large action models will actually orchestrate the work within each tool, put everything into parallel after it gets received in natural language, and then put everything into parallel. And then through that, actually commit unit testing and reasoning to make sure that there is no errors coming through, right? So it won't break like, role-based automation. If there is a problem, like you aren't logged into your Salesforce, right? Because it's coming in through the web browser, it actually come back to the user and have some sort of human in the loop and ask you to sign in. And then based off that, we'll then continue the workflow once you sign in. And one last note too at the bottom, we just presented this technology towards the end of last year at ICML, which we were super excited about. It's one of the largest machine learning and AI conferences in the world. So if anybody has any questions about really what's under the hood as well, happy to set up a demo and go over that a little bit deeper. And then how we actually execute this in the enterprise with different tools and interfaces, right? We have pre-trained models, like I said, large action models for common different enterprise tools. It can operate the browser through APIs and web browser automations. And then based on the user interface changes from company to company or user to user, it'll actually self-adapt and self-heal. So it's not breaking, and that actual agentic automation will continue workflows if user interfaces are changing. And then where we are in the competitive landscape, right? We are taking over the agentic automation space, in my opinion, right? As we start coming out of stealth, where we have built in a lot of rule reasoning and inferencing through our model, so things don't break, and we can offer a lot of success and high reliability throughout workflows, right? And it goes beyond just these co-pilots that are built specific for different enterprise tools, because those co-pilots for ServiceNow or Salesforce won't actually talk to other co-pilots. We're agnostic. We can orchestrate tools for a growing number of already existing tools, as well as proprietary technology. And then our Roomba, like I said, will self-adapt to customizable and changing tool interfaces. So if things change from a day-to-day perspective or a week-to-week perspective from VPs or whoever's operating those tools, our models will self-adapt and heal itself, so it can continue workflows and things can continue to work out of the box. And then from a data and privacy and security perspective, we can deploy all of this on-prem, and that's what we're doing for some of our largest clients right now. And then I'll bring this back onto the slide at the end of my demo, but if anybody would like to connect, here's our website. You could sign up for a demo, my LinkedIn as well. And without further ado, I'll go ahead and showcase a little bit of a live demo here. So bear with me. If there's any questions, feel free to put them in chat, and I'll go ahead and start the demo process now. Hey, Narada, can you upload this receipt to Concur, please? can go ahead and upload this to the Los Angeles trip. So as you can see here, it's taking context from the left hand of the screen, finding the total amount, finding the context of what this trip kind of entailed, and going ahead and then operating my browser, finding the right trip within Concur, and then filling out all the necessary items that I need to fill out to go ahead and actually expense report. And this is all doing it through the front end web browser automation, also uploading the receipts and providing all the necessary information of location, business purpose, the amount, and also a little bit of a comment there from there. And then it'll go ahead and finish that, communicate back to me, and we can continue with workflows. Let me end this example. I have one more example to show with you, which is what I showed to Natan a couple weeks ago. But originally, right, we had built this as just a note taker for individual knowledge workers. Anybody could use. You could still go ahead and use this for free today.
Fernando, can you unshare and then share your browser? Yeah, my bad.
No worries. Are you? Oh, did you not see that demo?
No, and I really want everyone to see it because it's like honestly amazing. So
do you mind if I restart that?
Yeah, you can restart it. It's cool.
Okay.
Yeah.
Did you hear the audio?
I can hear the audio. So
okay. My fault, guys. My fault. Excuse me. All right, let me go ahead and show you guys the Concur example right here. But for this example, like I said, this was product 0, right? This is for knowledge workers to use on a daily basis. But we're not limited to this, right? We actually want to go explore the workflows that are in the back office, right? That are ugly, that haven't been fixed, that are in deep enterprises, that are accounts receivable, IT, operations, HR. It doesn't matter. But for this sake, I'll show you what our product 0 can do. But let me go ahead and redo this demo. So I'll use our real-time API, but I'll go ahead and prompt it with natural language as well. So without further ado. Hey, Anote, can you upload this receipt to Concur, please? Can you upload this to the Los Angeles trip? Oh, let me restart that. Okay. I think I broke it. Let me restart this demo. Okay. Live demos, right, guys? All right. Hey, Anote, can you upload this receipt to Concur, please? Can you go ahead and just upload this to the Los Angeles trip? And as you guys can see, Anote is working through the context of what's happening on the left hand of the screen. So it's taking the price, the trip, the date, the time, the city that it's all done, and then operates my browser. My hands are up here and fills out all the necessary things that need to be filled out, like uploading the receipt, the location, the dollar amount, and even a comment given the context of my email. And we'll go ahead and just expense this for me. And it's doing this through API calls and also front-end browser automation. And we really think, as this continues to work, this is the future of work, right? AI agents, especially in the enterprise, we're no longer going to be flipping from tab to tab with different tools and going through work. We're just going to be talking to agents that could operate, browsers and different tools and automate different workflows. And I want to preface that I don't want you guys to think we're just limited to these knowledge worker examples that I'll show you again, what I just showed to Natan over 3 weeks ago. But we can also apply this to the dirty, complex workflows that are in the enterprise and the back offices as well. But this is the example that I showed you to Natan in a couple weeks ago, and this is product 0 for us. We originally built a note taker where our AI models can take the context of what's happening in your meetings, provide summaries, action items, and even meeting prep, and then go ahead based on those action items, actually take context and then operate your tools based on that context. So another quick example, I'll show you how I use it on a daily basis after I have meetings with clients using the real-time API. Hey, Narada, can you send a recap email to Tom summarizing the next steps and the action items, and also ask if he's available for lunch next week and suggest some sushi restaurants in San Francisco that we could attend? Awesome. Thank you, Narada. Can you also upload the meeting notes as well as an update that the PO should be coming in a month to Tom's HubSpot page? Did you cut out on me? Little delay. So as you can see here in the Chrome extension, you can see that Narada is thinking about, what the task at hand, planning task. I think I might have actually interrupted it, so it's going to figure out the context. The meeting notes from our call that you could see on my screen, Narada. Not as clean as a couple weeks ago, Natan. But for any of the audience that wants to see a demo of this, feel free to reach out to me. My email is fernando@narada.ai. We're starting to deploy this in enterprises. The note taker is free to use. You could download it and install it in the Chrome extension through our website at narada.ai. And go ahead.
Yeah, I personally like love the Narada product. I use it once like a day or maybe more. I'll tell you exactly like how I use it. So essentially, normally when I would basically have meetings, I would just email myself like a to do of something I would do, and then I'll never really do it, and I'll like eventually once a week like delete my to do list. Instead, I can actually just go into this Narada console and just tell it like in natural language query, like exactly what I would put on my to-do list in my email, and it'll already complete my to-do by drafting the email and getting it done. And just to kind of clarify, this is like actually like works like today in production. Like most times it works like really, really well. And furthermore, like this kind of computer use technology can be applied for a variety of different use cases beyond just this version 0, which is kind of the key point Fernando is trying to say.
Yeah, definitely, definitely. We originally just started like Natan said with this note taker, right? And my fault on it not working as cleanly it is. I use this every day, and it does work. But happy to run a demo through everybody. But if anybody it can see this being applied to the back office, workflows in the enterprise or for their organizations, please let me know. We haven't ran into a workflow that we can't tackle just yet. And if you have proprietary technology or other tools other than ServiceNow, Oracle, SAP, Workday, Salesforce, let us know. We're always looking to pre-train models specific to those, so people could use it on a knowledge worker basis, as also in the back office as well. Fantastic. Oh,
So
Natan, did I lose your audio?
I'm here, I think, hopefully. Can you hear me okay?
Yeah,
Yeah.
I can hear you perfect.
Well, thank you so much, Fernando, for like the incredible talk. Honestly, like when I say like this is an amazing product, and I just hope everyone checks it out and rooting for this team, and hopefully we'll partner for years to come.
Yeah, definitely. Super excited to now be connected, Natan. Thank you so much for having us.
Yeah. So I'm really excited for a few reasons. For one, we have an awesome MC coming to join us. Woo, Spurthy. Yeah.
Hey, Natan.
A round of applause. Fernando's talk obviously is amazing. Everyone definitely check out the Narada product, and I'm happy to kind of demo it for him to show how good it is. Next up, I kind of want to let Spurthy, kind of give a quick intro on herself and who she is.
Yeah. Hi, everyone. Really excited to be here. So I'm Spurthy. I'm currently a third-year student at Stevens Institute of Tech. I'm studying software engineering and also machine learning. And I've worked with Natan and Anote for over a year now on a lot of exciting machine learning research problems, specifically related to RAG and retrieval augmented generation. And over the winter, been getting involved with this really cool autonomous agents project as well. So I'm emceeing for this portion of the afternoon to introduce a lot of the cool series of presentations that kind of focus on a lot of the cool AI agent projects that people have been working on and practical applications of them. So for this slot, we have Deepa, who is a machine learning engineer at Yeshiva University, where she specializes in innovative AI solutions. So today she's going to give a presentation about how you evaluate AI agents, specifically how you leverage AI agents to then evaluate other agents. And she has a background in generative AI and full stack development and worked on this project. So I'm going to give the floor to her to present.
Thank you so much, Spurti. Nathan, let me try to share my screen. Okay. I hope we are good. Is it visible, Spurti? Okay. Okay. Hi everyone. I already appeared with my colleagues TJ and Manish a little bit earlier to talk about the Auto AM agent, and as of now, I'm going to talk a little bit about the evaluation part of the agents. Right now, I think people have given a lot of great presentations talking about agents, how we are playing with them in the playground, how we are creating them, how we are giving them persona stories, and making them work. So right now, let's get started. So the problem statement right now is that we do have a lot of different type of LLMs with a lot of capabilities. We do have a lot of tools in our hands which we can definitely integrate with the LLMs and create an agent. Now the problem that arises at this point is, how are we going to evaluate what content is getting generated, and how are we going to do the evaluations? Now there are two three things that definitely come into the mind when we are doing it. One thing is, normally when we are doing content generation or something, we start with like rogue score or F1 score, accuracy, and all these values to just see what are the similarities in the content that has been produced and the ground truth that we have. So in a lot of different cases, as of right now, we don't have that. So one thing is that definitely if you have the ground truth, we definitely go ahead and match it. But there are other cases where we are doing production level grade, production level coding, or we are generating cases where we don't have these ground truths available. So in that case, we definitely use a lot of benchmarks that we are coming up with. So they might not be very huge, but they are useful to match and see what is happening. Then there is definitely human evaluation. Now we already learned a little bit about human in the loop. That is like when the agents are performing, you go ahead and you ask them, what is going on, how are things performing, and we take the feedback and go on. Now human evaluation simply means that whenever an output is being generated, uh, is my screen visible? I am just wondering. I think it is, right? Yeah, okay. When we are talking about human evaluation, it simply means, for example, we have created a piece of code for Sudoku, and now we are wondering if it is working or not. So we can definitely create a small UI piece, like where human doesn't have to spend hours and hours or write a lot of stuff in there, but they can definitely do yes and no. right? So when they are saying that, okay, do you think this is working fine, the human can just give a feedback, yes, this seems fine. Then when the user feels no, it doesn't suit what their needs are, so they can say no, this is not working fine. So in that way we can at least put like one particular person, a user, and we can definitely have different people, like a person in that industry, a manager at that industry, a person with little experience and a person with more experience, and we get 10 type of different users to give feedbacks, and that we can definitely store in the memory, and our LLM will get trained, or our agent will understand what kind of answers or content that is getting generated is more appropriate according to the scenario. Now agent as an evaluator simply is, again, we are going to use the same frameworks that we have. I'll discuss a little bit about that in the next slide. But normally agent as an evaluator is again going to be an LLM with a particular tool that it might need to do the access, right? And now we have like few things that are definitely important. It's like we have to definitely talk about the quality that is getting generated. We also have to see which particular LLM is behind which agent, which task, and how much it is costing, so that we put every appropriate thing. Latency is super important, because when I was doing the we were doing the demo of auto ABM, since it was running on our local, there was latency issues and it was a little bit slow. So that is like one feedback we can definitely take. Then of course performance, what kind of question is thrown by the user and what kind of output is given, how is it interacting, is it able to understand what is given, is it able to reciprocate or not. Now there we already know a lot of these frameworks, so I'll not spend a lot of time. We know AutoGen, LangChain, LangGraph, Crew AI, AgentPy. All these are the same frameworks that I right now I'm trying to make kind of a small demo that is not yet ready, but I'm working on it, so that I can try to see how the agents that are working can be evaluated, so we can use the same framework for them. I have some definitely good websites where they are doing great work, so you can definitely go and check out these things. These are really really helpful, and they will kind of let how the entire thing is working, how the agents are working, how to evaluate them and everything. They also have some of the repos available. This is one from Open Hands. This is very good. I am following this along with few more. uh, so okay, these are few more things. So there are different benchmark systems right now in place. For example, this is like majorly based in the field of coding or GitHub type of field, where they have these things. Okay, there are some scenarios that they have already handled. Then Web Arona, Minivo we can use for web browsing, for general like question answers and talking and creating normal content. We can definitely go with these ones. These are just something we can have a look at. Now when we say that agents evaluating agent, it simply means that we are creating agent as a judge. And we already have heard about LLM as a judge. This is just taking it one step further. And here we are just that's like LLM as a judge is the basis, and then on top of that we are putting tools as well as more prompting, more persona to our agent, so that it is able to evaluate. Now okay, so this is a very interesting paper released by Meta. I will share the link later on, but here we can like I think this picture actually represents a lot of information and clears a lot of doubts. For example, if we are talking about LLM as a judge, at the very beginning we go with the user. Okay, a user is asking a question, then there are, let's say, two three LLMs giving some outputs. LLM A gave this, B gave this, C gave that, and then LLM judge comes and just simply tells you that, okay, I feel this particular LLM performed well and this is my matrix. It just gives you the output, right? Now when we go as human as a judge, that is simply the same process, but in agent A and agent B there will definitely be some workspace and some environment variables. And then as a user I have to sit there and I have to do the analysis of what has it performed. And I also have to take a lot of pieces of code to copy paste myself. For example, if I'm asking it to create a snake and ladder game, it will probably generate a Python file. So I have to copy it, I have to run it on my system, I have to also install the variables, I have to create a virtual environment, and then see if it is working or not. If it does work, then I'll be like, okay, it is fine. That is human as a judge. Then agent as a judge is we don't need all this. So it will automatically have a set of tools, for example, let's say Docker, Python accessories, and all these things, where whatever code is being produced, it can run it on its end and see if it is working or not. And then, on top of that, we can definitely have human feedback. So this is agent as a judge is like a package of LLM as a judge plus tools plus human involved, but the human doesn't have to put that much time of effort to do the entire thing. So this is what. And Meta also released a very nice, it's not very huge, but a dev AI data set which comprises of 55 realistic AI tasks, and we can definitely use that for evaluations. There are definitely other benchmarks also, Meta GPT, GPT Pilot, Open Hands is the one we saw earlier. We can definitely compare with these as well. Now this is my best part. Let me show the, yes, okay. The way the agents as an evaluator work is that they start from the very basics. Let's take this agent as a judge, evaluate agents with agents. This is the paper that Meta released. As an example, what do it do is, for example, we are asking any code. They are firstly going to divide that into tasks, that what are the tasks, what kind of task I have to do, and they're going to just write it down, mention it. Then locate simply means they are going to check into your repository or folder access that you have given. They're going to see which files are needed for making that particular change or executing that particular thing, and they are going to fetch that. Search is basically to look for the objects or things that we need in order to complete that, maybe do a web search, get more information out of it, and find that. And retrieval is again whatever tools you need and whatever kind of information you need back to in order to do that. Read is not always necessary, but if you have already a pre-written code or things that is already there and you need to do a little bit analysis, and you go ahead. And then ask is definitely whenever it is working, it keeps continuously asking humans that this is what I have got until now, this okay with you, should I go ahead. We definitely have memory and planning with the entire structure in place, because memory is needed in order to have everything shifted there, and planning, it continuously keeps on planning, because the human, as far as it goes, whatever changes are suggested and everything, we have to keep rearranging things. That is how it works. But yeah, definitely go out, check this paper as well. I really like it. They have a lot of information in there, not a lot of technical details per se, but I feel still good enough. And I think we can definitely use this benchmark data set in order to do it. I'm trying to get that demo in place as I'm speaking, so maybe in the coming few days or something I should be able to show it. But as for now, this is what I'm able to discuss with all of you. And yeah, thank you so much uh, for having me. If you have any questions, please let me know.
Thank you so much, Deepa, for that great presentation. AI agent evaluation is definitely like a major thing to look into, and especially as they like scale automating it with other agents is definitely a really exciting place of like research and development. So next up we have Jasper Levy, a graduate student from Cornell Tech, specializing in computer science and machine learning. He has a background as a solutions engineer in at least AI and data analytics, and he's going to be talking about agent optimization, specifically talking about DSPY and model optimization for fine-tuning agents and evaluating them.
Hey, guys, how are you doing? Well, thanks so much for Deepa for the talk. I'm gonna let Spurthy take over this. Yeah.
Hey, Natan, is the next speaker, there he is. Okay. Yeah, the floor is yours, Jasper, if you want to introduce yourself and start your presentation.
Cool, and you can hear me?
Yes, I can hear you.
Awesome, okay, cool. Yeah, so today I'm gonna be talking about optimizing and abstracting prompts with DSPy. So the whole goal of this is to say goodbye to prompt engineering essentially, and DSPy, which I'll get into in a little bit, is a framework out of Stanford NLP. And as was mentioned before, I'm a grad student at Cornell Tech. So what's the problem with prompt engineering? There's really two main problems. I know there's three things kind of separated here on the slide, but the two main problems are that it's quite labor intensive, can lead to a lot of trial and error. And then it's also hard to scale when it's labor intensive. So it's kind of impractical to generate prompts manually for very large systems. And there needs to be a way to kind of optimize this and streamline this process so that it's very simple, intuitive, and quick, so it doesn't take so long. And then another key thing here is that prompt design demands a deep understanding of both AI models' behavior, the data within the AI model, and the inputs and outputs, as well as domain-specific knowledge. So requiring specialized knowledge is very important in order to generate prompts that are effective in giving good outputs. So what is DSPy? DSPy is a framework for programming language models, and it's designed to program language models through modular components. And this is aimed at moving on the traditional prompt engineering. So essentially the goal is to kind of abstract away prompt engineering as much as possible. And DSPy is used for optimizing and fine-tuning prompts of modern LM systems or language model systems. So there are a few key use cases that the DSPy library and framework provides solutions for. And we're going to get into one of these in more of a deep dive, but generally we can see things like chain of thought reasoning, retrieval augmented generation, multi-hop QA, document summarization, React agents with disposable tools, entity extraction and classification as all things that can be tackled with the DSPy framework. So it's a very powerful framework and there's a lot of things you can do with it. So as I said before, the whole goal of DSPy is to say goodbye to prompt engineering. And there's a very cool article I recommend to read by Lawrence Liu on PH Data. And he's basically discussing and explaining this. And it abstracts prompt tuning away from humans. And at a high level, this is done by algorithmically optimizing a prompt towards maximizing a given metric by comparing prompt output results to an evaluation data set. So to sum it up in this diagram here, what we can see is that all the developer has to do now to generate these really effective prompts are define the expected behavior. And this is generally done by providing input and output examples. And this is done with a signature, what is called a signature in DSPy. And we'll get more into that in a little bit. And then you also create or use an existing evaluation metric to evaluate against so that we can optimize the DSPy program. So after that is done, all you really have to do is use the DSPy optimizer and start the optimization. It iteratively fine tunes a prompt to maximize the evaluation metric of the provided examples. So another cool thing about DSPy is that it's inspired by PyTorch's modular design. So essentially there are complex functionalities within both of these frameworks, and the way PyTorch works is through modules. So we have this class here as an example is a neural network. It inherits from a neural network module. So it has a bunch of different properties within that. And then it builds on top of it. So we also see similarities in terms of these class-based structures or modules that are built for programmability and also for generating models, or in DSPy's case, programs or agents. So this is really good for clarity and reusability. It's quite intuitive. And then they both also use the initialization method and the forward method, which is, that's kind of one of the main mirrors of PyTorch within DSPy. Obviously, they're very different frameworks that tackle different problems, PyTorch being for building models and then training models. DSPy is kind of more high level, and it's for training these programs or agents or language model applications. So this gets into a big part of this presentation, which is MePro v2. And this is multi-prompt instruction proposal optimizer version 2. And there's a really good paper on this. I recommend reading it. This link is here. But essentially what happens is this is an optimizer that enhances performance by both optimizing the instructions and the few shot examples. So in the past, DSPy has offered CoPro, which is another optimizer. And by basically what CoPro would do is only optimize the instructions, but it would fail to really optimize few shot examples, which can be generated or augmented or pulled directly from the training data. So what's really cool about MiPro V2 is that it optimizes both the instructions, which you could think of as like system instructions for a prompt, as well as optimizing the few shot examples, which it can generate through bootstrapping or pull directly from the training set. So how does it work? Essentially, it aims at maximizing a downstream performance metric, such as an accuracy or F1 score. So usually this is going to be some sort of accuracy metric. And without access to, it does it without access to the module level labels or gradients. So it's kind of very abstract. And essentially, we are just trying to get better output values for our entire program, right? And we're optimizing for that. So the way it works is it bootstraps few shot examples. So it generates candidate examples by sampling from the training set and validation outputs. And these can be question answer examples, for instance. And then it also proposes instruction candidates. So it creates instructions based on the task dynamics, program code, data summaries, and few shot examples. And then lastly, it has this key feature here with Bayesian optimization, which essentially allows for search to find an optimal combination of instructions and examples. And this is how it selects the optimal few shot examples that are used in the final model to get the highest accuracy. So essentially what we're doing here is finding the best combination of prompts, and we're generating stuff along the way to get the highest accuracy at the end for our language model program. So to briefly go over the setup of the code for this, you need to install the DSPy library, and definitely recommend using Python, very intuitive. Configure the language model in your environment. So this would just be importing. And then we'll get into this in a second, but there's many different language model providers that you can use. I used OpenAI for this example. Then we configure the program. So this is what I was going back on before with the modular approach to programming these types of applications or types of programs. So here, this is a chain of thought example, which I'm going to dive deeper into in a bit. But essentially, we set this up here, and we have this signature. So this is defining kind of the flow of data. And we're going to input a question and what we want to output an answer. And then we also have this forward function for defining execution. And then finally, we can run this program, and it makes use of the OpenAI model that we're using, and then we can print the response. So to quickly go over compatible providers, this is the current version. We can use OpenAI, Anthropic, Databricks, local LLMs on GPU servers, local LLMs on your laptop, any scale models, Together AI, Amazon SageMaker, and Microsoft Azure. I know there's not compatibility currently for Gemini, but hoping that comes by soon because I'm a big fan of Gemini and want to build more with this. So with that being said, I'll go into a little deep dive of a code example for how this works and how we can optimize a chain of thought program. So this is a QR code that you can use to go to this notebook, but I'm just going to click on this to go to it directly. I'm just going to open it here then. So let me see if this works. Yeah. Basically, in the code here, what you can see is we install the required packages, skip over that. We import and configure the language model for DSPy. So this is what I do here I use GPT-4o Mini, and I use the OpenAI key, which I have. I believe it's in user data. Yeah. So I use Colab user data for that. And I'm using the grade school math 8000 data set. And this is essentially just grade school math problems. And this is basically a good data set to use for running chain of thought problems. So essentially getting a question answer or having a question answer type of I guess, like structure, but also within it, you will want to have like a reasoning as to why you come up with an answer. So whenever you're going about a grade school math problem, we want the LLM to reason as to why an answer is a given way before it actually spits out the answer. So this is the module that I discussed earlier. Sorry. This is the module that I discussed earlier. And here we evaluate it with zero-shot setup. So this is essentially just prompting directly with no prompt that we've optimized, right? So
Hey, Jasper, we can't see your thing you're sharing right now.
Oh, okay. Let me try to reshare. Sorry about that. Can you see it now?
Yeah, perfect. Yeah.
Cool. All right. I'll just briefly go over what I might have missed. We have installation up here. Then we import and configure the language model. So we instantiate it with GPT-4o Mini and use the OpenAI key for that. Using the grade school math problem data set as mentioned above, or as mentioned before. And then we define the chain of thought module, which is what I went over in the previous slides. So this is essentially what we're optimizing the prompt for. And as we can see, again, very similar to PyTorch's kind of modular layout for training. And then the next step is evaluating with a zero-shot setup to essentially see, without any examples or without any tuned prompt, how high is the accuracy that we're currently getting. And we see that we have an 86.3% accuracy, so it's not bad. So now I'm going to get into a bit of optimization. And here we set up the optimizer. So the optimizer has a few different modes. We have light mode, which is a less extensive search, and it's cheaper. And then we also use medium mode in this example too, which I'll get into later. But what we're doing here is we're essentially running the optimizing. We're optimizing this program that we came up with here, right? And we're also keeping track of the history so that we can calculate total tokens and total cost. So we have visibility over how expensive this tuning is going to be in terms of cost and tokens. So yeah, as you can see, this is just the verbose output for the tuning and optimization. And for this example, we have this many tokens used, and it costs 9 cents, which isn't bad. And then, as we see here, when we evaluate this trained or with the tuned prompts, we actually get a higher accuracy. As opposed to 86, we get 92, which is great. So clearly this works, and we want to kind of look into trying different hyperparameters for this. So this is just an example showing what I just mentioned. And here, this is also pretty cool. We get to see the few shot examples with the reasoning. So these are the ones that are included in the prompt actually before we run the new evaluation. So these are the ones selected by our optimizer. So yeah, now we can look at, yeah, sorry, 1 second. Yeah, so this is another example of just using a different setup with hyperparameters, which I'll get into in a bit. We can just skip over this. We see it has a lower accuracy, but still higher than the zero-shot accuracy. And then here is another example. Also, this includes the system instructions this time. So essentially, this is the optimized system instructions on top of the few shot examples generated for this tuning. Finally, we have another one with separate hyperparameters as well, a different setup. And then we get a higher accuracy of 93%, which is great. And then we also can see the cost is similar with the light mode, and also the tokens used is similar. Yeah, so then I'll go into medium mode, which is essentially a more extensive search, and this takes longer to run. Skip through this for a bit, it's verbose output. And then what we can see is that we actually have the highest score we've seen so far, which is really cool. So yeah, essentially, also, here, let me go down to this. Okay, so very interestingly, we see that this costs about 50 cents, which is a lot more, about 5 times the cost of the light mode. And it has kind of marginal returns. It's a little better than the 93% or the 93 accuracy that we had before, but it's not really significant given the amount of cost or the magnitude of cost more it costs to run this. So yeah, and we can see, I'll just skip through the last examples because it's essentially the same thing with different hyperparameters, training on the medium mode. And yeah, I compiled the data, and I'll just go back to the slide real quick to go over the data that we collected from this. So for our optimization results, we have here we see the zero shot has the lowest accuracy, and this is zoomed in, keep in mind. So we also see that there are like significant improvements using the light mode. Oops, sorry. Yeah, so there are significant improvements using the light mode for these 3 light mode hyperparameter settings, and that's great. And we also see for medium, we have actually the best with the original hyperparameter settings that we set up. We have the best accuracy, and that's great. But it's really interesting that as we spend more with tuning, we don't really see a necessarily equivalent, I guess, improvement in accuracy, right? So there is very much a diminishing return happening here. So here we kind of see again that there is essentially a diminishing return here in terms of accuracy. So here we're including more augmenting examples, which essentially means we're including more generated bootstrapped examples, and we're still getting like pretty similar accuracy as this one over here. And then these ones are more interesting. Here we see as we increase the cost that we are the spend for tuning these programs, we still improve our accuracy, but it's kind of marginal after this point here. So this begs the question of like whether or not we actually need to spend this much money, or if we can get away with just using the light mode and kind of optimizing with these hyperparameters. And then we also see something similar here with unaugmented examples, but yeah. So briefly to go over other use cases, there's RAG, as I mentioned before, and we can use semantic MiPro v2 with a semantic F1, essentially to optimize prompts for RAG systems. So very similar process, just with a RAG use case. And then with React agents, this one's really cool. We can optimize for a React agent, and this involves optimizing multiple prompts and few shot examples, potentially for different tools, with the goal of collectively maximizing a metric for the entire agent system. So everything is kind of abstracted when you create a React agent, and this is all done under the hood, so you don't have to worry about the individual modules and tools that you're using. And then finally, we also have multi-hop QA. So this is a really big use case for this type of prompt optimization, and we can use MiPro v2 with a top recall metric or top 5 recall metric or so on. And this can also improve the recall of the multi-hop answer documents. So essentially, are we getting the golden documents that are necessary to answer the question, the current question given to the model? So yeah, and this is just a small example of the code for a React agent using DSPy. Yeah. So,
awesome. Yeah, thanks so much, Jasper. This is like an amazing talk, I guess. Anything else? Yeah.
Yeah. Just this is the final slide. Sorry if I'm going a little over, but just mentioning the difference between key frameworks. So like, why would I want to use this over LangChain, Llama Index? So these frameworks are really cool, and they help developers build agents and retrieval pipelines. But the key here is that these still often require developers to rely on manual prompt engineering, and DSPy is really good at automated prompt engineering, and basically eliminates all this manual prompt engineering that's necessary. And as we can see with the coding example, we had an increase in accuracy with that, so it was great. It also provides a modular structure, and it's very intuitive. I know there's a very big learning curve for some people using LangChain at first. And it's also built around this automatic optimization fine-tuning. So it's really the goal of using DSPy is more for observability and also optimization of the entire pipeline or the entire program that you're building. Yeah, and that's it.
Thanks, Jeps. Thanks, Jasper, for that great talk. That definitely sounds like a really cool framework improvement, more structured way from prompt engineering. For our next speaker, we have Anelia, who is a student at the Academy of Art University, and she's pursuing a master's in arts in artificial intelligence and design. And today she has a really cool presentation about AI-based marketing agents, specifically integrating this marketing platform with blockchain for personalized ads. So I'll let her take the floor.
Hello, did you see me?
Yes, we can see and hear you, and we can also see your screen.
Okay, perfect. Hi. I will share where I'm working now, and it's so interesting, speaking and don't see the people. Okay, so the main idea what I am talking is about coming from my real experience. I mean, I used to work with a lot of clients, and everyone don't care about how much people working, or outsource freelancer. They just care about result at the end. I mean, every Friday I have to provide reports how much we spent for campaigns, how much leads we did, about our sales funnels, how we reach our engagement goals and stuff like this. And it's always, it's still my proper purpose why I am doing this all stuff. And I want to start with like our tech gurus, with Mark Zuckerberg, who say that I think we are going to live in a world where there are going to be hundreds of millions or billions of different AI agents, eventually probably more AI agents than there are people in the world. A lot of what we are focusing on is giving every creator and every small business the ability to create AI agents for themselves. So it's like when I start to use your product from Anote, Panade, I start to just play around like other my own task. I'm like check and start to research others tool. It's like more than 600 nowadays AI agents, and every huge company have own model who work for themselves, and it's look like we really have to fast to adapt with these technologies that we are working on. And these main problems what I am I have, and I think all marketing departments have, is like our data from any sources is isolated. I mean, for social media we have one data. For CRM we have another data. It's not connected with each other. Even production team who will do some campaigns, ads, or avatar, also working with a different kind of data, and everything. It's look like we have to work with it. And another problem is about targeting. Marketing is what we target, which client we want to attract, who is the person, what he's doing, and it's different type of also data. And another problem, it's like all marketing messages, or the comments or feedbacks is coming and sometimes lost because of different demography, or because the client was asleep or didn't don't have time to write the correct way, so and with so anyway, I am now in California. I start to go out. I start to speak with tech guys, and everyone talking about Elon Musk vision that he will produce the next. It will be even more than humans, and we also have to be ready to work with that, and with this all stuff, I just think, why if we will now start to implement AI agent into robots, and it will be based in blockchain. Yes, I know it's all look like difficult, but who say that it will be easy? So it is from how it's called, from Anote presentation. Yeah, it's logic that I think every agents have similar logical system how it's work. So, but the my idea, and I already speak with Big Z. It's he is a developer. I'm like, so what do you think? It will work if we will connect with AI agent with blockchain? And he says that could work, but we need a lot of fine-tuned adjusting or knowledge of context to outperform just proving data at AI. So main idea, the robot will replace a lot of teams and agents and provide, real data, real reports, and like RGBT, but with more physical interactive way. Okay, so it's a hackathon where okay, I will share with you. So this hackathon where like 1 week ago or 2 weeks ago we participated, and the engineers and I together start to start to real work with robots, but from Key Scale Labs. It's another company. Also, Natandera, very welcome to work with you and your teams. So, and spend like 2 days and to just make this robot dance, and it's look like everything possible, but we need more time and resources. It look like we are so early stage. Even we have a lot of dreams with our AI agents, but it's also I also appreciate that I'm speaking and it's recording, because like after a few years I can prove like, yes, we started to work, and it's really interesting that we are all right place, So this is how we do.
In team number 6 has reinvigorated my professional outlook, and I am currently acquiring new skills with a focus on dance. I am learning new moves on a daily basis, following the beats, and aiming to spread joy and positivity in my work. This incredible journey would not have been possible without the support from Kenneth, Anand, Anelia, and the opportunity from the K-Hacks Humanoid Robot Hackathon on January 18th, 2025.
Yes. So another news like 2 days ago was from NVIDIA company that he already say that their agentic AI can replace a real all team, and they can do everything, from real data, or from real, how it's called, real video making, or to email, or some very difficult stuff. And you know that it's so interesting that soon will make a decision every agent more clearly, and we have to make sure that the data will be secure and more transparent. It also will help the owner who have this business to see how real inside the business working. I mean, how profitable is it, how the campaigns in the marketing real working, because everything what we are doing now with hands, even use AI, it's make us a little bit do human errors. But if it will be very clear and transparent and smoothly, we just have to use the knowledge that we have from company, from data, and from history, and to create another strategy, or to maybe change A/B testing. I think it will give a lot of different perspective. Yes, and the main AI agent solution, I think it will be like intelligent data aggregation. It means it will provide a unified view of customers, and of course predictive analytics is like to see future customer behavior and market trends, and agents can deliver tailored marketing messages. So I am already finishing with another startup. It's coming. It's just launched from Stanford accelerator. So they are already analyze personal data, and through the model AI, they see which agent will work with different behaviors. Same, I think, will be everywhere. Another step, it will be to implement. Yeah.
No, yeah, I think we're a bit over time. This is like an amazing presentation. I guess for like the audience kind of listening in, do you have any kind of like what would you say is like the biggest kind of takeaway from all of this? Yeah.
Okay. Okay, thank you. Yes, thank you, everyone. Thank you, Nathan. How we can help, we will help with collaboration. And a lot of people want to work with your panacea. Yes, it's what I want to say.
Thank you so much. I really enjoyed this talk, and it was kind of cool seeing you kind of talk both about LLMs in the hardware space with like kind of K-scale, as well as like what NVIDIA is doing, and then on-device personal AI. And we'll definitely kind of have a follow-on conversation to kind of understand all this and see how it could apply to kind of the stuff we're doing with Anote and Panacea. So appreciate you.
Thanks, Natan. Now for our next speaker, we have Stephen Liss, who's the co-founder and CEO at Open Ads, where he's going to be presenting and giving a demo of his product of how we can have generative ads for the generative internet. So I'll give you the floor.
All right, thanks everyone. Everything's live here. So hey, I'm Stephen, co-founder and CEO of OpenAds.ai, and we are the first company to provide real-time generative ads on AI content at scale. So we power ads on over 15 million AI conversations per month. And if I have one goal for these next 15 minutes, it's to help expand your conception of ads beyond what we've known them to be over the last 25 years, these annoying rectangles that ruin the internet, into a new form of information and something that's really essential to how humans, AI, and information interact. So I'm going to start by sharing a presentation basically on some of the case studies we've run and really how to think about the economics of information on the AI internet. So quick about my team. We're a collection of veterans from advertising tech, from AI, and really we find ourselves at this very interesting intersection where much of advertising is very behind on AI, and much of AI just has not been interested in advertising. So we started Open Ads about 2 years ago, really from three first principles. One was that AI was going to disrupt how people access information, which has definitely been borne out. The second is that whatever form AI and media take is primarily going to be ad supported. This is true for Google, for Facebook, really any form of information where even if you do have a subscription model, offering a freemium service expands your reach. Like you can even see this happening with Netflix lately. And finally, the third principle that we founded this company on was that eventually AI would get good enough, fast enough, and cheap enough that you could have real-time customized ads for every single impression in real time. And that's something that only became possible really late August, early September of last year through a combination of foundation model improvements and hardware improvements. So ASICs such as Google's TPUs, Cerebras, Grok, all of these are finally able to get us the tokens per second necessary to do some really interesting things with ads. So really the way to think about ads is all information has a retrieval cost. So when that retrieval cost is positive, that's like when you're searching for information that you need a subscription from Crunchbase or something, or even if it's free information, there's still some cost to hit a SERP API or just the web infrastructure to read Wikipedia. On the other side of this axis, where the retrieval cost is negative, that means there is information that wants to pay to access you. And that's what really advertising is. It is information that wants to provide money to reach an audience. And so really the future for advertising, we're seeing diverge into two directions. You have ads for humans, where we're using AI to power these interactive experiences in real time. And you have this $100 billion question of how do you influence AI decision making? And that's something where that fundamental understanding of ads as information with negative retrieval costs, that's how you start thinking about how you provide these almost sponsored content data feeds to be available to AI agents. So we've been running these ads over the last 3 months. We're the first company to demonstrate that AI ads work far better than traditional ads. So we've seen in head-to-head tests of static pre-generated ads versus real-time generated ads, a 56% improvement in click-through rates. So this is all fairly abstract. So I'm going to show you some examples of what these ads actually look like in action. So here's an example of a AI search engine. This is a search reasoning platform. And if I ask something like, how do I train for a half marathon in 8 weeks? Actually, I think I only have 7 weeks. We'll ask our query. And in the time that, oh, great. So while the AI is still thinking of answers, we generated this ad specific to the user's question. So unlike traditional ads that are targeted and pre-generated, this one is actually riffing off of the user's query. So it knows that I'm training for a half marathon. Comp your goals, your half marathon. And it is offering, let's see, the right fit to find shoes for training. So in addition to being relevant to the user's question, we also have the ability to put AI inside the ad itself. So we can ask about how does their community help my training? And this is currently searching over all the information we have about this company. And okay, they offer discounts, list races. So this is a powerful experience for advertisers and much more positive for users. And it's very easy for us to onboard additional advertisers this way. Since Anote is hosting us, I'm going to demonstrate just how easy it is to bring on another advertiser. So all we need is a domain, anote.ai. And this is going to basically do what a human agency would, is scrape the site, learn about the company, and we can see examples of if someone is searching an AI for how do I improve the accuracy of my AI model, for example, these are the ads for Anote that we would generate. So this is already loaded into this example search engine. And so if I'm asking how can I annotate large data sets for ML training, this is how Anote would be represented in here. And we can even ask questions like, this isn't a decision tree, this is all live chat with the brand. And yeah, it's this opportunity to interact much more deeply with brands in a way that advertising really just becomes information that you didn't know you wanted to know. So I'll stop sharing there for a moment. And are we doing any sort of Q&A?
the main question I have is, how can I use this? This is like probably better than any ads I would do. Yeah.
Yeah, so it's easier and a lot more affordable than Google because you're not competing with every other company that's on Google Search Network. Before I was in advertising, I was shocked to learn how much Google makes from just clicking navigation links. Like, we're talking 20 to hundreds of dollars per click. So that example of going to that brand search and just putting in Anote.ai, that is literally all it takes to onboard. Like, we'll also need a monetized link that you're monitoring on your end. So a link that tells you they signed up for the service, and really the rest is just hooking up Stripe and paying us when people book the ads.
Yeah, it's really cool. I guess I have one more question, right? So we've actually had like a few like inbound customers and people who like been looking for us on like Perplexity, for instance, right? So they're asking what are great tools to do like fine tuning on like unstructured data, right? And then it will kind of like pop up Anote. And I'm assuming like in the future, as these chatbots get more and more popular, like obviously there's going to be like insane inference costs for each of the models. So it should make sense for them to just kind of have ads related to kind of like companies to use. So like, what's it kind of like if you're trying to go to someone who has their own chatbot that is trying to like monetize and make ads on them? Like, how do you kind of prove like the quality of your ads, and is there kind of like a way you do it?
Yeah, so it's the way we think about this market is you have AI search and chat, which is really interesting. That's the demo I just showed you. And that's something where we're working with a lot of those companies in that space. And a lot of the concerns are around how do we make money without sacrificing user experience. And so far, we've been able to demonstrate that pretty decisively with those click-through rates. The other part of the market is there's just a ton of traditional publishers out there. So for example, this is just an article on a news site about AI inference, and we're able to generate these ads in all kinds of formats. So this is an example of an ad we've designed for Anthropic, where we've actually put Claude inside the ad, so Claude can sell Claude, and we can even ask it like, is ChatGPT better? And let's see how Claude answers this query. So really the potential of putting AI inside these ads means it's not just these dumb rectangles. We can have a pricing calculator in here. We can have product demos. The ability of some of the new coding models like O3 Mini to develop these means ads become less like just JPEGs you traffic across the internet and more like an application programming environment where you can put in anything you like. So we could put even an example of Anote inside this ad and say, enter in a string and we'll do named entity recognition on it.
Thanks, Stephen. Sounds like a really awesome product and a great overview of that. Definitely something needed in changing landscape of advertising. Next up, we have Vanessa and Maximilian, who are from Big Picture, who will be doing a presentation and example of how to build your own agent. They both have a lot of background and experience in this field, so I'll let them take the floor and start their presentation.
Hey Vanessa, I don't think I can hear you at all. And while we do this, I'm just going to share a link to my QR code to join our Slack channel. Ooh, yeah, you see that? All right, join, yeah, all right.
I don't think, maybe try seeing if like all the permissions are enabled. So
Yeah, unfortunately, I can't hear anything, Vanessa. All right, I guess Vanessa, I'll be right back. Just fixing some like audio issues, technical difficulty. Spurthy, do you want to just kind of give like a brief overview of this amazing in-person event we're doing tonight at CIBC in New York?
Sure. So, yeah, for those who want to join us in New York City this afternoon, it's gonna be a fun time with pizza, drinks, and a lot of really awesome speakers. Natan is gonna be talking about a lot of the cool products that he's been working on. And launches, and then I'm going to be giving a presentation on like autonomous intelligence. So you've kind of like seen like a lot of great presentations throughout the like morning and afternoon of people kind of going into a lot of like the specifics of different like agents, of different agents and aspects of it, whether it's developing specific agents or like specific use case of them, or like monitoring or like evaluation. So just kind of going to be giving a big picture of it, and specifically like this cool like open source project that we've been working on, a lot of people like presenting have been working on. So, and then it's going to be like some networking opportunities too, to like meet cool people who are like interested in this space. So if you are available, you should definitely join us for those like talks. I think there's going to be a lot of cool startup talks and demos, right, Natan? So it'll be a fun time.
Yeah, we'll have, I think, 10 to 12 startup demos from like some of the leading AI companies in New York City. We'll have 30 pies of pizza, which unfortunately will probably get devoured really quickly, but I'm not going to order more, though maybe I should. Maybe. And then, yeah, you know, we're obviously going to be launching, I think, five new products today that we hope will have a really big impact, not just on like, you know, profits, but also more importantly on making AI more accessible and bridging the gap between the everyday tasks people care about and the tremendous potential of AI models, which is why we're hosting this AI Day Summit in the first place. So I'd say Spurthy also, she didn't really talk too much about this, but she'll be sharing a really cool talk on multi-agent AI systems and recapping an open source project we worked on this winter. So tune in for that. Yeah.
Yeah, definitely. Yeah, it's cool because you kind of got to see a lot of the more specifics with the presentation, and then like mine will be more of like a high level overview. And like over the winter, I kind of got the opportunity to act more of like a project manager for like a lot of people working on it, of like and it was cool to like manage and see like what different people are like interested in, and like find intersections between that to bring them together and make a community around that.
Yeah. So without further ado, I'm going to play some cool music, which is actually something I've been preparing for this event. Tell me if you think this is AI generated or not, and what theme do you think this is? comment in our Slack.
I am back, I guess. Can you hear me now better?
You are back, and we can hear you very, very well.
Thank you. Thank you very much. I just changed my computer. Thank you for your patience. So yeah, I'm going to present you an AI agent that went live in Europe, so in Germany, hi from Berlin, already in September. So it's from a logistic company, one of the biggest one in Germany. And here the discussion is really to see how we could bring it in the market, so in production. Because as we saw today and the precedent events, AI agent is getting really a lot of traction. It's almost as famous as generative AI right now. But what we saw with other also studies from Accenture, for instance, is that a bit less than half of the projects are stuck in proof of concept. So why that? What we saw discussing with our partners is that every company at first is trying to do their own project, their own AI solutions, their agent, their chatbots, but then they reach a point of accuracy which is not reliable and it's not a good solution for big businesses and enterprises. So we saw that in 2025, it must be soon the year of the agent, but we already launched one, and I'm gonna show you later a little video to see what exactly is the agent doing and automating. And then after that, I'll show you what is inside those agents. So regarding big picture, we are an IT company in Berlin, part of the Experience One network, and work with a lot of automotive solutions, also in the health and finance industry, for instance, with some of our partners for more than 10 years. The case here is from Frege Career Claim Management, and was rolled out then a few months ago right now, completely productive, so it's working right now. And we build it using Microsoft Azure with a Logic app and Function app, and we can present it as an agent workflow, agentic workflow. Here you go.
The Frege Carrier Claims Management System is an implementation of an AI worker, finding lost parcels and demanding compensation from carriers. The system works fully automated from the first email to the claim resolution. The system can read and analyze a client email. It writes a mail to the carrier asking for information or demanding compensation. It analyzes the carrier answer and checks whether they fulfill their contractual obligations. It then either continues to process the claim with the carrier or closes it. Let's start. A new claim reaches us by email or via other channels. It may consist of text, PDF, images, and other documents. The claim is analyzed and read into the system. But let's take a look under the hood. The AI worker can read and process text, images, or any other media. The AI uses so-called reasoning. Like humans, it thinks before answering to get better results and to make the answers comprehensible for human users. The system detects that something is missing in an email. Based on templates, it writes an email to ask for more information, completely automated without any human support. A reply to the first email is sent within 60 seconds. Upon request, we are also happy to wait a little longer so that it doesn't look like magic. The system can keep all information warm until the customer message arrives. As soon as the missing information arrives, it can write a mail to the carrier with all relevant information. And remind them if they don't answer in time. In the event of a rejection of claims, we check the email very carefully. The model can understand emails in each and every European language, making it easy to process any email. By reasoning, it can detect what the other side is writing. And if they are wrong, they have a tireless and diligent counterpart in our system who won't let them get away. When the carrier writes their final reimbursement email, the system can close the claim and inform the client accordingly. Such a system can process 70 to 90% of all claims fully automatically. It can massively reduce the workload of your support team and contribute to a major increase in efficiency.
So that was for the solution in itself. And go to the next slide. Here. So how we developed this agent that was actually hired by a company. We say hired, but it was completely brought to life with the company in itself. It's completely customized from their own system. We see that there are three blockers generally in the AI adoption for those agents. Is the accuracy, the autonomy of it, really end-to-end everything from itself, and the acceptance. Are there new tools? Does it make sense in terms of ROI, for instance? Regarding the accuracy, we saw that hallucination-free processing is actually possible. How so? By not letting the model completely or directly communicate with the customer. So we sandbox it, and then all what is around is with the workflow, the agentic, and with RAG processes. What we also do when doing the output, so for the answers that are going to the customers, is filling templates. So we ensure that the generated output will not be hallucinated. They can have minor errors, but it won't be hallucinations. How we make a prompt. So here you can see a little example of what people might think an AI agent prompting is. And on the right, I will get in the details a bit later, what it really looked like. So for this particular case. So here we see that a lot of background instruction and output format is really important. And all together, it was about 4,000 tokens without the context data. And it's really important also to give examples and counterexamples from the answers that we are supposed to get and to give. Then the autonomy is another key that really allowed us to put it on the market, it was important and crucial for our customer that it could work alone. So what is really important for the company when they do AI project is not just to use another tool, but really to do the job of a department, of an end-to-end process, and then to help them growing their business. I'm going to go a bit faster in that because we all know now what are AI agents. And here we can be ambitious. So 80% of automation is possible, which doesn't mean 80% of correct answers. So we put a threshold and we say, okay, when are you confident to process the task and when are you not confident? So yeah, we can focus on 20% of the cases, which are not edge cases. So we really get the most impact of it in terms of save of resources or generation of resources. Here you can see that the handover to human team is something we can really put ourselves. So we discuss with our customers, when do you want to put the handover to the human worker, and when are you confident for it to let it go alone? Another part is the acceptance. What really helped to go in the market is to do KPI-based agreements. So we will say we process X% of the case fully automatically, and then after we get the money accordingly to if we kept the promises or not. Another part is then the team which will use it. So we convince the management how easy will it be to use the system. We build the integration of the AI agent in order that there's no system change. It's just another worker that will then use the same tools as our team is already using. Here to summarize the best practices for an implementation of an AI agent, accuracy, autonomy, and it's really important to put effort on the prompting and to avoid hallucinations. Another part which is really important and that led to the success of the implementation is working together with, we call them our hero, that are either part of the company or another, say, consultancy team, change management team, which will really get into the implementation of it and the use case definitions. Thank you very much. Here's my LinkedIn and the one of Maximilian, who did all the article, which is based on. And thank you also for the patience for the little technical issue.
Thanks, Vanessa, for that presentation. Next, we are going to have Priyankshi Gupta, who's a graduate student. Oh, Priyankshi Gupta and Dave Ashar, who are both graduate students at Cornell Tech, studying computer science, and they are going to be presenting topics about agent monitoring and multi-agent interpretability, specifically with a demo of Ecosys. So happy to have you guys here, and feel free to start presenting.
Okay. Sure. Okay. Okay, is my screen visible? Okay, perfect. So, hey everyone, Dev and I are from Team Ecosys AI, and we're trying to build a multi-agent powered platform that so your engineers can go from looking like this to enjoying your coffee in the morning. We are Priyanshi, Jay, Dev, and Jack, and like 4 of us have been working on this project. So our vision is to like imagine a world where engineers don't have to slog through endless logs and misaligned tickets, where you can just create amazing stuff without having to do the manual triage and admin work. And we are on a mission to give AI ML teams super smart, multi-agent systems that automatically spots, sorts, and ranks issues. Think of it like a personal assistant that never sleeps, giving you crystal clear insights and taking care of all the boring stuff so you can focus on cool, game-changing ideas. So let's rewind a bit when tracking issues was like the Wild West. Before Jira, you had like fragmented communication, that you had bug reports in your email threads, requests in spreadsheets, and you did not have everything in one place. You used different data storing tools, which caused a lot of confusion and lack of visibility. And there was no clear system to prioritize which feature you have to build. And it was hard for all the members in our team to collaborate when everyone was working in isolation. Then entering Jira in 2002, it built a platform to streamline software development workflows, and they put everything like home in one place, and where you could get comments, notifications, and make sure that everyone was in loop. They had specific sprint boards that would like support your agile methodology, and then later they also they also launched Confluence, which helped teams collaborate and document their work. And then they launched Bitbucket, which made version control easier. And they even acquired Trello, which is good for small teams. So using their tools, teams saved a lot of time, having a single source of truth and reducing duplication and chaos. Now let's see who is Jira actually serving. So they built it for like software development teams and like now ML teams and web dev teams. And you can see that a major chunk of it is ML teams. Um, but why does it fall short for MLAI teams? So first reason, that you have to constantly chase logs and keep on changing tickets, and most of the MLAI work is ex, uh, exploratory instead of following strict sprint deadlines. And it has so many features, but for MLAI teams you don't actually have to use that many, so teams still pay for a lot of them, and their UI is also not that good. And uh and then because there's so much information regarding, like, as AI grows, the logs keep on increasing, and how you measure its performance keeps on increasing. So as the world evolves into an AI landscape, Jira natively doesn't actually track that, and your team can go like this emoji, like picture here. And some of the quotes from our market research of what are people saying, that like there's so much backlog that you end up creating a ticket to clear up the backlog. And so let's try to figure out what makes it actually inefficient for ML teams, that once their approach solved a big problem, but because of the experimental workflow of AI ML teams, it's no longer that useful. So it's because you have to create like user stories separately, and it does not have the AI integrations that can support experimental tracking and model performance. And it has a very complex setup, and it like to track for your MLAI teams, you need very heavy customizations, and you spend a lot of time like putting tickets instead of actually working on your model. and I think I've covered this before. So this is the like project management software market, that there are so many companies that even with all of these tools, Jira still owns 85% of it. um, and like now our solution, that how we're thinking of flipping the script. So if you have an automated root cause analysis, that you can figure out whether issues stem from the data or model configurations, or if it's an infrastructure issue, or if your code is not working. So to remove the guesswork and to reduce debugging time. And then you also have to ensure that tickets are actually routed to the right member, whether it's an ML engineer who has to fix the problem, or is it a member of the data team who has to like fix the problem. So most of the time when you actually get the issues from your product testing, you don't actually know which team actually like has to fix it unless you go through the log. So when in triage meetings you initially assign the problems, it is usually a lot, like there's usually a lot of back and forth, and this is because they're not able to actually see what is happening inside it. They're not able to uh, see where exactly the issue is in your AI system, because there may be multiple layers of AI that you have in your system. So there's no way to observe what exactly is happening, and there's no way to customize what metrics are important for your team. And then you also don't know which issues to prioritize initially. So you spend around like 2 to 4 weeks going back and forth fixing the uh, same issues, and your agile methodology is not rapid anymore. So now, what makes our solution a game changer is, firstly, we are aiming to have we have a multi-agent workflow where every member of the team gets their own smart agent that digs into the details, fetches relevant logs, and serves up customer insights. You have a central orchestration, which is mimicking the role of a product manager, where it like talks to all the agents and it figures out which logs it needs, and it ranks based on severity, and it's able to auto assign it to the right person. And then we have the third feature is the no code custom agent integration, that you can add and update agents without you writing a single line of code. Like you can easily integrate specialized agents without having to retrain it again. And then the fourth is having a context based metrics and unified observability, that our dashboard would showcase the metrics that mattered the most, like based on how are you going to evaluate correctness, how are you going to like what would correctness and precision or accuracy mean to you, instead of how they are generally defined. And then having it in a dashboard format where you can get a laser vision into every layer of your system. And like in today's rapidly evolving AI landscape, companies like Crew AI, LangChain, Hugging Face Spaces, and Llama Index are redefining how data is accessed and utilized, and pioneering agent driven approaches that streamline everything from knowledge retrieval to integration. With emerging RAG capabilities powered by Pinecone's vector search, these platforms are now setting new standards for intelligent real time data processing. So this surge in agent and multi-agent frameworks not only enhances data observability, but also creates a significant window of opportunity for our solution. So by leveraging specialized agents that automates or like autonomously monitors, classifies, and prioritize issues, our system seamlessly integrates with this ecosystem, transforming raw data into actionable insights and driving proactive and automated issue management capabilities in complex AI environments. So now they will show the demo of how our like initial MVP looks like.
Hello everyone. Let me just share my screen and see if. Yep. Can you guys see my screen? Okay, perfect. Let me start. So this is our initial dashboard. Obviously, the UI is not up. What it would be eventually. This is our MVP right now, where we have all the functioning agents here. So what we would do is, let's say there's a product test that has happened recently. Let's say these are the QA logs. These are not essentially non-technical logs, but like showing what is expected and what is supposed to come out of this. Let's say this is a example for the voice agent. So for the voice-based app. So let's say the user query is what's the weather like, voice assistant responds with something, and then we get the logs for this. So here the error log is none. But here in this case, for the same query, the QA person got a voice assistant response unable to fetch weather data, which was due to a API fail. So now what we do is we click the enrich button here. And now what this has done is essentially our orchestrator has sent this entire initial log to our central agent. The central agent figures out based on the logs that what log is relevant to which team in the company. It sends the logs and the request to the agent for that specific team. So let's say this goes to our data pipelining team, that's the MLOps team, or the and few others for the NLP ML team here. They get these errors, and they have specific agents then ask the user for the logs for these specific time ranges. Let's say the error happened on 3rd March 2023, and they ask for the range, get put the entire error log into the agent. The agent understands how that log is relevant to the error that had occurred based on the initial log we had provided, and creates an entire summary of the logs, and then eventually provides a more enriched log here, which would look something like this. Let's look at the intent recognition errors here for the NLP team. So we have multiple more fields added here, like LLM explanation. This is where the LLM is explaining what the error could have happened and how it could have happened, and making it more human readable. LLM confidence score, assigned team, and these are the required log ranges. So this is where we have like a action button towards for the team that has to, like, okay, we've sent the logs to the agent, and we're done with the process. That is what this mentions. As of now, we do not have the integration. In the future, our plan is to have integrations with products like Slack, where we can send this notification to the team. They get a message on the channel, they upload the log, and everything else is automated after that. But as of now, we are just picking up the logs for each team. And this is our entire MVP as of now. Yeah, handing it over back to Priyanshi.
Okay. So, yeah. So now that this is where you come, we're looking for forward-thinking teams and like startups to collaborate on our pilot programs that integrate our like issue management system, where you can discover real-time insights, intelligent assignment, and context-based insights to transform your AI-driven environments. You will get the advantage of being early adopters, where you can enjoy customized integrations and have a direct influence on our product, helping tailor our solution to your unique workflow, and to also drive innovation together. That in this new world of like where AI is taking over, let's partner and build something really cool. So this is how you can like contact us and sign up for a like pilot program, or if you have any other query. So if anyone wants to scan this, and then we have our, and you can also help us like help our research by sharing your experience, that what are your pain points in this whole AI development cycle, so we can cater to your problems as well. So thank you.
Thank you so much, Dev and Priyanshi, how are you guys doing? Obviously, we would love to do a pilot with you guys, and I will scan that QR code.
Okay.
Well, thank you guys. And I guess we're over time, so I'm just gonna leave from the call. But thank you.
Okay. Thank you. Bye.
So next we have actually an exciting project of a lot of different people. A lot of my friends and people I know personally. We have Megana, who's I actually have known for a bit, and she's a student at Cornell University, studying computer science. And then we have Rishabh, who's an AI developer at AI Camp. And then we have Andrew, who, like me, is a student at Stevens Institute of Technology. And also Xavier, who's a grad student at Cornell Technology. And over like the past month or two, they've been working on this SDK for the agents and doing a lot of development regarding that. So I'll let them take the floor and if you guys want, you can give an intro and present on all the great work you've been working on for the past few weeks.
Thank you, Spurti. So, hello everyone. My name is Meghna. I'm a sophomore at Cornell, and I'm majoring in computer science. I've been working with Anote and working on the project for about a month or two now. So, yeah.
Andrew, I don't think we can hear your audio if you're talking.
Is everyone going to introduce themselves?
Yeah, so hey, I'm Rushab, mostly self-taught. I've been working on this project with Meghna and all other folks, and I'm presenting the slide right now, so yeah.
Okay, so the goal of our project is to define the structure of the agents in our SDK, add the fields that are relevant for the agents to create an end-to-end system where the agents can either go in a sequential order where the output of one agent serves as the input to another and all of them work together to accomplish a certain task, or the agents can be configured to run in parallel to accomplish a certain task. Once the SDK is completely built, our final goal is to make it like a PyPy package so that users can interact with our API using an API key. So next slide, please. The previous one, yeah. So I have talked about all of these things, so I just want to clarify on the definitions of each of them. So an agent is an entity that can complete a task using certain tools, which are and tools are external APIs or any external services that the agent accesses to complete a task. A task is a job or work that is allocated to the agent, and the agent can just complete that end to end. So the fields for the agent vary. Different agents have different fields, but basically, an agent always has a name, the model that it uses, the system prompt, the task, which is the work that is assigned to it, and the tools that the agent uses to complete that particular task. A crew is a group of agents that work together to complete this task. Next slide, please. Yes, so I clarified on all of the definitions of an agent, the task, the tools, and crew. But what is an SDK? An SDK is just putting agents together, allowing users the functionality to create their own agents, specifying certain tools and certain tasks that the agents can have so that they can perform the task end to end, and also giving the functionality of making the agents work together in the end. So we ensure that the user has access to basic CRUD operations, which are create, read, update, and delete operations to perform on the agents or tasks through our SDK. We also ensure that the tasks and the tools are properly configured, and we only assign certain tasks and tools to certain specific agents. Next slide, please. Yes, so this is the SDK that we built. It matters because, and it is a SDK that allows users to create agents that can schedule a meeting in the Google API, in the Google Calendar API. So it matters because managing multiple tasks manually is very time consuming. Meetings are scheduled without considering weather. And this is important because if the meeting is taking place outdoors, it's very important to know the weather conditions, and because they will have an impact on the travel plans. And there's a lack of automation in personal assistance. So currently, I have built some basic aspects of this SDK that allow users to schedule meetings on their own Google Calendar with the help of an agent that parses and interprets the meeting notes that the user has collected. So the idea is that the user takes down certain notes from a meeting, and the agent uses those notes and parses and interprets the certain times and dates that the meetings have to be scheduled. And it interacts with the Google Calendar API to schedule the above set meetings. Next slide, please. Yeah, so this is some of our code. The first picture, I would say, is the curl operation in our terminal. So it is the post request that allows users to first create an agent. And as mentioned, the particular agent here is the calendar agent. We give it the specified fields, that is the model, which is GPT-4. We give it its particular system prompt, the task, and the tools. And as you can see, we see a success message saying the agent has been successfully created. The second image is that of a meeting notes, like I said. This is the example of the meeting notes in my local machine. So it has to be written in a specified format. So the first two lines describe the tasks for some of my team members or even myself. And the last two lines describe the particular meeting times and the dates and what the meeting is about. So then in the third picture, I have written another curl operation that does a post request to this endpoint, which is ingest meeting notes. And that endpoint is responsible for both interpreting the meeting notes and getting the particular time and the dates, and using that to schedule a meeting on the Google Calendar. So the final picture is that of the schema.sql file, which has the tables for the AI agents and the tasks. The agents table has all of the agents that have been configured by the user, and the tasks table has all of the tasks. Next slide, please. Yes, so the picture on the left shows the ingest meeting notes method that allows users to both interpret and interpret the meeting notes, and it calls the schedule meeting function in the calendar agent. That, one second, I'm not able to see it. Yeah, okay. So the schedule event function in the calendar agent that allows the agent to schedule the meeting at that particular time. And on the right, we see the calendar agent class that has the schedule event method. Next slide, please. So yeah, so my meeting notes had the note of scheduling a meeting on March 15th, 2025 at 8:40 a.m. UTC time. And as you can see, a meeting has been scheduled at 4:40 a.m. EST. So that was the result of using my agent. Next slide, please. So for added clarity, the agent in this case is the calendar agent that the user creates. The task assigned to the agent is the manage calendar events task. The document is the meeting notes.txt file on the user's local machine. The tools the agent has access to are the Google Calendar API in this case. So the added improvements in my mind that I wanted to make for the entire SDK to work end to end is to make an agent crew by allowing another agent to get access to the weather in the location and add the date the meeting is scheduled. And this can be called the weather agent. The weather agent can then pass all of this information to the calendar agent before the calendar agent schedules this meeting. We can also have a stock market agent that gets the latest stock price. And this can be relevant for certain meetings that focus on that, focus on getting relevant information about the markets. And I think this just makes it more convenient. Once all of these agents have been configured, we have an SDK, which once built out entirely is an AI-driven task automation SDK that has many use cases, one of them being allowing startups to ensure that all of their teams have their meetings scheduled automatically. And this reduces a lot of time and increases the efficiency of the entire workflow. So yeah, this is just summarizing the workflow. Currently, the text processing agent functionality has been included in the calendar agent. And like I said, we also have the weather agent and the stock market agent that work together to ensure that this is done. Rishabh will take on from here.
Yeah, thanks, Meghna. So we mostly talked about the parameters. I think Meghna already mentioned about the parameters that the agent received. So this is what the parameters that an agent received when we create an agent. And this is the agent initialization code. So we have an initialization with the init that sets up the agent with the specific prompts and then the handle user input. And it generates a response, which uses OpenAI's API to process the conversation history. And then this is an example on the bottom. I took a screenshot of my curl request. I was successful right here when I invoked the when I invoked the model, and I got my agent. So our goal was to mostly create a CRUD agent that's able to create, read, update, and delete. And then as you can see, the parameters are here with the system prompt and task and tools. And the verbose parameter is mostly for debugging. So if it's set to true, then you can get additional information on your console. And this is the example of task, which I was mostly working with. So a task object is created with details like instructions, uploaded files, examples, expected output, and an agent. For example, for a file processing, if a CSV file is uploaded, the function reads the file using pandas and calculates summary statics of the salary column. And the data summary is the salary data is summarized using describe method, which provides statics like mean, min, max, etc. And then returns process data. And some tasks, they also require, multiple agents. So if the task is complicated, it has to be small chunked into multiple agents. So this is a screenshot of how multi-agents talk to each other. So there's an agent creation, and you can assign the agent, and then there's a crew execution. With task assignment, 2 tasks are assigned to the agents, researching stocks and performing market analysis. So I took this from the documentation right here, and it kind of mentions right here. So to use the other interesting thing I found is that the tools you can add tools in the list, and you can call multiple tools. So as you can see, you can call the Serper dev tool and the scrap website tool. So you can import agents with these, Serper dev tool and scrap website tool, and then you can initialize them, and you can create the agent with these tools, and you can set the verbose mode, and then you can append the scrap site to the list like we're looking. So I think for me, it's really leveraging the tool functionality, because if you want to call multiple tools, you can sort of run a for loop and just go through those tools and see which agent to call. So that's mostly what I was interested in, because agents can automatically complete tasks. So something I was trying to research on was, what if the system prompt like indicates the task the agent is supposed to complete? So maybe having some sort of like package for the tool, so that users don't have to consistently install like all the required tools, right? So Like here is agent validation. So it checks if agent name exists in the agent directory and it executes the tool, and then the results is collected right here in here on my screenshot. That was another request I made. And you can see like there are more than one tools here. So DuckDuckGo, Google Search, Wikipedia. And then this is the final agentic workflow. So we create two agents that plan, which is planner to outline event steps and executor to implement them. So the assigned task or the plan task is the task, right? So plan task instructs the planner to create an event plan with a variable number of sessions. Execute task assigns the executor to carry out the plan and summarize the results. And this is basically the workflow. And then you can create the kickoff execution with number session, triggering the planning and execution steps. That's mostly it. I think the next step is to just figure out the system prompt that and task that invokes the right agent without worrying about what agent to invoke. And user basically provides instruction. And each agent, my opinion, should small chunk the task and divide into subtasks so that agents can kind of work collectively. I guess biggest takeaway has been just working through enterprise level application and navigating the code base and delivering a working product aligning with the product's vision. So one of the vision is like in the front end, users can basically drag and drop the agents, and the back end will mostly handle all the intricacies. But yes, that's mostly what we learned about. If anyone else wants to go, you're welcome to.
Can you hear me now?
Yes.
All right, I'm gonna try and speed through my part real quick. So I did the use cases. Can you see my screen? So I'm gonna speed through this. So one of our use cases could be an autonomous AI coding agent. The current problem right now is software development is time consuming, with developers often spending hours debugging, refactoring code, and handling repetitive tasks. Companies need a way to automate parts of coding process, such as generating boilerplate code, suggesting optimizations, fixing bugs, and things like that. So in practice, what this would look like is first a user would input a path to a code base. Then you could send this to a feature generator agent, which gets a well-defined set of features that it gets by analyzing code base for improvements. And you can see this here where it reads an app.js and the feedback agent returns like what it thinks it should do. Then it sends those features to a software engineer agent that outputs code that is needed to implement the feature, but does not update the files just yet. You can see like all the new code that's generated from the software agent. Then when it gets finished generating the code, it sends that code to a reviewer agent that enhances the code for readability, maintainability, and performance. And you can see the changes, it outputs the changes that it wants to make. And then this goes on to a section manager agent whose responsibility is to implement this new feature back into the code base. Then finally, a pull request is made for the new features, and the different files that need to be changed all gets done autonomously. Another use case is Upreach, where there are 4 easy steps to this agent. You search a keyword, you unlock profiles to get into a list, generate tailored emails, and auto send messages. For searching a keyword, one search of a keyword uses AI to query through thousands of data sources and returns targeted results in a fraction of the time. This allows you to access hard to reach contact information of the best fitting prospects. There's also a filtering system to narrow down your search to get more specific leads. And now to contact these leads, you can unlock the targeted profiles and add these contacts to a specific list, tailored sequences. Then for the generated emails, use GPT-4 to craft compelling emails that are tailored and personalized towards each prospect. And another use case would be a data labeler agent, where you can start off, what you would do is you would upload a data set, and it can either be like a PDF or an email or a CSV, or you can connect to like a social media like Twitter or Reddit. And then what you can do is you give the data set a name and search for a value. Then what you would do is customize by adding classes that would define a tweet. And you can choose between a word match or an entity match, where a word match would be a certain word is seen in a tweet and you would classify it for the class and that you want it for. And an entity match would be if the tweet is relating to a certain entity and you can also classify it how you want. Next, you would start annotating where a tweet is rendered on a GUI that has your class labels to choose from. You would read a tweet and choose which class it would belong to, or you can skip it. The GUI shows your annotation history, so in case you made a mistake, you can remove it. You can then see all the tweets and the class that was predicted by the agent alongside what you annotated, as well as the probability score. And then finally, you can download the CSV with the label data. And finally, another use case would be a AR-RFP agent. Normally, filling out grants takes hours, but with this agent, we reduce that time down to minutes. First, the pipeline outputs an original response for the grant application, and it makes calls step by step to OpenAI for each question that the grant requires, so it doesn't use up all the tokens. This original output usually isn't that specific or precise, so we make a second call that gets revised, more precise response. This revised version gives more specific details for the grant we are trying to apply for. And then using this, we can create a technical volume for the final grant that needs to be submitted. And this has everything the grant asks for in a more concise manner. And yeah, that's my part.
Yeah, guys, I think we're like way over time, so I'm just gonna have to cut this. But you guys did like an amazing job, Xavier. I know you had a lot to say, so we can kind of find like another time to and go through that. And obviously, this agent SDK is like really powerful and is very much related to Drew's next talk. So we really appreciate your guys' like contributions on this. And thank you.
Thank you.
Thank you, Nathan.
Thanks, Nathan.
Hey, Joe. How are you?
Good. Can people hear me okay?
Yeah, I can hear you okay. Yeah.
Okay, cool. You can see my slides okay? Oraclex AI Agent Framework.
Yeah.
Okay, great. Thanks so much. My name is Joe. I'm the founder of Oraclex AI. I'm also a professor at Columbia University. So I've been working on AI for the past 15 years, going from the very natural language processing into now large language model, now going more into agentic work that actually can perform actions, not just talking about things. So today we're just a little bit background. You have heard about AI agents for so long, and then you have different definitions of what AI agents are. So particularly, I'm here just using the classical Russell Norvig agent framework that agents usually needs to perceive the environment or the world through multiple senses like text, image, audio, and through consuming these information to be able to think. So here, when we call an inner monologue, it's really coming down to reasoning what's going on through a large language model, through a chain of thoughts, these. So you can think about you're really breaking down big intentions or big tasks into multiple steps, and then learn how to coordinate with different tools, different functions to interact with the environment to complete tasks. So here, the actions are really how the agents, like the AI agents, are going to influence environments, like your tool callings or even embodied actions, moving from point A to point B. And there are a lot of new research and also engineering ideas that come in through the large language model area. For example, the reflection. How do you do meta reasoning better so that we can actually have a better planning system throughout the execution of the task? So if you think about the real application, these AI agents could actually serve on various purposes within an enterprise. For example, before we're actually buying softwares and humans are using these softwares to complete tasks. Now these agents can actually take actions themselves. So they're really sort of a teaming that you can have with your human agents. Together, they can coordinate on what the AI agent's going to do, what the human agents are going to do, and then together become more powerful, more productive team in general. So AI agents could shoulder on different responsibilities, various other tasks in order to supercharge the entire organization. So we're really looking into the organizations are going to be more efficient through AI agents coordination. So we have seen this graph of agent ecosystems a lot. So we start with foundation models, and then we can have foundation models specifically tuned for agentic tasks. And then we can have the agent orchestration framework. So basically utilizing the foundation models, coordinate in between of the tool reuse, safeguarding, and various efficiency and security optimizations to actually make these foundational models to be useful to complete tasks. And then the last is you can actually have different vertical applications that is dependent or extended from the orchestration framework. For example, you can have an AI agent just do customer service. You can have an agent just do cycle consulting, right? All these kind of verticals can be a specific functionality of one particular SaaS product. So my company Arclex is mostly focusing on the agent orchestration layer, which is really help developers and also designers, product managers to be able to design their own vertical applications without building all these kind of building blocks and system optimizations. To demonstrate our orchestration framework, we also have one or two vertical applications centered around customer-facing AI agents to demonstrate the ROIs for these various verticals. So let's take a little step back in terms of how do we do AI orchestration. When we start from the very beginning, we have seen like AI has been used for simple automation. So you write these kind of scripts. Whenever this happens, you do this. Right? For example, Canva or HubSpot, these kind of scheduler is what we call simple automations. And then after 4 or 5 years ago, we go into this, what we call AI workflows. We're actually basically defining these kind of prompting of the large language models to do one task. And then if something happens, you do other steps. So this is what we usually call AI workflows, which is very useful in terms of that you have very defined, well-defined knowledge. But also these kind of flows are very rigid in a way that you have to manually edit and maintain them. If your workflows are very complex, it's very hard to maintain. You can think about like Zendesk, AI agent bot, like answering customer service question is one good example of that. And then now we will go into the new era that we want a fully autonomous agent. Doesn't really work on the flow, that just does the reasoning and then decide which tools to use and do various complexity to solve the task. But still, the issue is there is a huge cost in terms of you're actually doing the search every time you encounter a new task, which can be very expensive. And there's also uncertainty and inconsistency robustness within it every time you run it. So one of the examples we see is like these kind of coding agents like Cursor. So what we do see here, that is sort of a nice segue in terms of how can we actually make sure these agent can be both controllable and flexible enough, is really combining these two type of workflows together. So you can think about these original AI workflows are great because they actually condense the domain knowledge so that it reduces the search complexity for these fully autonomous agents. But at the same time, you also want to equip the agent to be able to explore other opportunities or other traces when the AI workflow doesn't really hold all the solutions for it. So what this is our entire framework is based on in terms of the concept. So how does really Arclex work? So we start with how do we design these kind of task graph? So the task graph is really for different steps. How do we decompose these complex tasks? What kind of tools to call for every individual steps? And then how do we sort of like construct these tasks? Traditionally, when we look at a conversational agent system, you have to manually craft them. But right now, we can take unstructured information, for example, your sales playbook, your customer service playbook, and then use that as an input And then we have this automatic task graph generator to help you generate the graph. And then once you generate the graph, you can also, because it's a deterministic graph, humans, these kind of operators, like our customer service agent experts, can look at this graph and adjust and verify how good these graphs are through an interactive visual task graph editor. And then finally, when we say these graphs are, you can release them, well, one of the important thing is, what if the humans who are interacting with the graph, or when the agent is set out to the realistic time, there are certain corner cases you're not covered, right? So this really requires the extra flexible planning that AutoCollect provide. So basically, we can automatically update these graphs based on the new information. How does it work? So during the test time, we'll try to figure out if you can navigate and complete the task through the task graph, which usually is the most efficient way of doing it and covers probably 80% of the time, all the corner cases. And then while for the other 20%, what you can do is you can automatically explore additional paths through the flexible AI agent planning algorithm that we put it in. And then, of course, given certain safety constraints, given budgets, you would have to hand over to human when certain cases are not executed. And then, but when you hand over to humans, so basically humans are actually teaching the agents how to do the things. So you can iteratively update your task graph by incorporating these additional successful paths, either through automatic exploration or from human teaching. Then you basically are actually, over time, continually growing your task graph to cover more and more corner cases in order for it to be deterministic, controllable, but also flexible in terms of execution. So this is why we say compare to the traditional task graph-based conversational agents. AutoCollect is more intelligent because it grows its ability over time. While on the other hand, for other AutoGen, which is fully autonomous in execution, you don't have this kind of controllable graph or deterministic graph that you can show to people to demonstrate what is the security, what is the approval that these kind of graphs could give human interpreter or red teaming as a sort of assurance. So AutoCollect is really coming down to we are open source. We have various properties that we sort of inspired from realistic task and also our research over time. So I'm not going to go down to individual features, but if you are interested, definitely check out our open source toolkits. So for example, we have the continuous learning, which is our most biggest selling point, but we also have task composition, human interventions that also have better enterprise deployable features. One thing that I want to show you is how you can grow these task graphs. For example, we're looking at a sales agent for e-commerce. And then what you're feeding it is basically some of the sales playbook, some of these kind of like playbook tells you what are the different steps that you usually do, like reading, ask about product type, and blah, blah, blah. So you can actually use these unstructured information as input and then use our graph generator to generate this graph that conveys all these kind of different steps, different tools, different APIs you're going to call. And then you will be able to use these tools to do simulations of how your users would interact with your agent. And then you can see for these individual user utterances, you look at what are the APIs we detected, what are the NLU intents you detected. For example, like this, it learns how to apply like your what we call promotions, like your why settle for just one when you can have two, get a second dress in any color for 50% off, right? So this is basically, it automatically pulls the promotion API and understands the information and can generate these utterances by itself. And then what if, for example, my promotion changes, right? Today it's a full promotion, tomorrow it's the Black Friday promotion. So all these informations are stored in certain databases you can retrieve from an API. So what you do is the agent would be real-time pulling this information and regenerate or update these task graph automatically. For example, we go from buy one, get one into get 30% off your entire cart. And this information will be populated automatically into a new graph. And then so the outer ends could change into, do you know that you can enjoy an extra 30% off when your cart total exceeds 100, right? This is our unique Black Friday sale. So this is one of the things that we have used as sort of an example for a SaaS product, especially e-commerce. So we integrated with all the Shopify APIs. You can very simply sort of spin it off and get all these toolings to connect to your APIs and be able to build a 360 customer service agents. So in general, what we were looking into is Arclex comes in with various different algorithms that do the optimization to reduce human supervision, to reduce engineering time specifically allocated for building all these flows. And we also have an enterprise version, which is a Kubernetes container that already optimized for machine learning infrastructure. So it can show them millions of people interacting with the agent at the same time to be able to optimize for the utilization. We are an open source toolkit. So if you're interested in trying out different tools, feel free to just go onto our GitHub, simply pip install Arclex. You'll find most of the toolings. You'll find documentations and tutorials. And we really welcome you to join our Discord community and contribute your own agents. It could be anything. It could be any function or any personal usage. Happy to do more interactions. If you're interested, reach out to me at email. Thank you. Okay.
Thank you so much. Really appreciate you taking the time to speak today. Obviously, it's like a super interesting and relevant topic, and I just kind of recommend everyone kind of check out Arclex. And yeah, thank you.
Thank you.
So yeah, next up we have my friend Ji Kwan. Hey.
Hi Nathan. Hi Nathan. Hi. How are you doing? Good to be here with the AI Day Summit.
Yeah, it's great to have you. You know, as you know, I've been kind of using Lutra a lot. It's one of my favorite products out there for a variety of different use cases, from finding venues for events to creating speaker introductions. I'll let kind of you actually introduce yourself and kind of give an overview of Lutra. And thanks so much.
Sounds great. Thanks, Nathan. Yeah. So for those of you who don't know, so I'm Tichan Niam. I've been working in the AI space for a long time now. Stanford was an early employee at Coursera, helped to build the first online machine learning classes. Was at Google Brain for a few years doing applied research, and now working on a startup called Lutra, where we're trying to help more people automate things. Is my screen being shared? Yeah, can you see that? Perfect. There we go. Yeah. So let me resize this a bit so it's a bit bigger. That's okay. So at Lutra, what we are doing is that we're going after what I think of the automatable task hours, right? So there's 62%, and this is a McKinsey report in 2023, where we think that 62% of technology in 2023, we can automate that amount of task, right? And the question there is, how do we get there? How do we enable people to automate more? So as you heard Nathan earlier, he actually used Lutra to go through all the speakers and figure out a bio for every speaker that he can use in his introductions. But doing that is not easy. So let's talk about why that is not and how Lutra comes in the picture. So one of the problems in automation is that when you think about automation, you start thinking about this, complicated diagrams where people are like wiring things up, figuring things out. And there's often a very high setup cost involved in creating these automations. And you need to sit down and really, figure out end-to-end workflows, processes. And that cost can be very high in terms of automating something that prevents us from actually doing any work in automation. So instead of doing that, there's a new future, I think, that's coming that many of us are very excited about in this room, in this AI Day Summit, which is, what if AI can take on a bigger role for us in going from idea to execution? Now, what is it like if instead of a person having to wire things up and figure out all the details of the automation, we can have AI that designs, runs, debugs, and creates these automations for you? What would that look like? And will we be able to really automate much more easily? So a lot of the concepts in here, a lot of what you see are going to be very much like AI agents, agentic solutions. So instead of telling what we're working on, I'm going to show you instead how this works. So I'm going to share my separate demo screen in here. Perfect, thank you. So this is Lutra, and this is the platform that we've developed. It is conversational, in which you can talk to it, it will proceed to do things. And I'm going to do a demo in which I'm going to connect Lutra to a Gmail account. So this is a demo Gmail account where you can imagine getting emails about different topics. Let's say you're a podcaster and you're getting emails about guests being on your podcast, sponsorship opportunities, or maybe listeners reaching out to you. And you got to figure out which are the most important ones to answer. Usually the guest ones are really important. So in Lutra, you can conversationally tell it what you want it to do. Hey, Lutra, could you go and find emails in my Gmail labeled with demo? So I labeled all the emails with demo, and now I'm giving Lutra an instruction to go find them. And Lutra takes my English instruction and figures out how to convert that into software, into code and actions that then retrieve and get those emails. So you can see here, it is running, is searching my Gmail for label demo, and it's showing me the results as it goes. And so one thing we're thinking about building agentic systems, it's really important to have that user experience that transparently shows users what happens, allows them to dig in further if they want to, also allows them to interact with the platform in a very natural way. So in this case, I'm going to ask it to do a next step here, which is to classify the emails. Lutra, could you categorize these emails into categories such as podcast sponsorship, a guest email, a listener feedback, someone trying to sell me something, or something else, another category? Oh, and let's put all these categories and emails that you find into a new Google spreadsheet. Great. So in this case, I'm going to tell Lutra a next step in here. Now it's got to know my emails. A very natural thing to do that you might want to do is to make sense of them, analyze them, extract information from them. If you're working as a person in shipping, you might want to extract out shipping details of where things are going, the delays, and so on. If you have in finance, you want to get things out like the invoice line numbers, when the invoices are due. Very similar work in here, just that in this case, we're doing a demo on podcast emails. Right, so Lutra is natively integrated into many systems, including Google Spreadsheets. And so when it works with the spreadsheets, we've created an artifact-like experience where you can see what it does as it's processing. Right, so over here, Lutra has created a Google Sheet showing me inline what the Google Sheet looks like. And then it's proceeding now to classify all the emails using an AI classifier behind the scenes. Right, so this is an AI calling a separate AI function that goes on to do work there, right? And so this is this whole UX experience, I think, is also really important because one thing that we notice from users is that when something is happening, they like to know what's going on because is the AI keeping on track? Is it going off the rails? And being able to see what the AI is doing at every step helps them understand that. You can also click into here and actually see how the AI is performing the task. So in this case, we are using another LLM to do the categorization, and Lutra has essentially created its own prompt for that LLM to do the classification. Cool. So now we see the emails coming out, being classified, subjects, categories, and they look pretty good to me. And the next step in here that you might want to do is to do like further work and extraction, right? So for example, maybe you like to say, hey, Lutra, could you find for those emails that are guest requests that you found, could you extract out the guest name and the company or organization they're affiliated with from the body of that email? Let's create a new worksheet for this data. So we can now ask Lutra to do more and more in here. And as you kind of do more and more, what happens here is that Lutra is in the background figuring out all the different APIs you can work with, all the different actions, composing across them, and making that work for you. So I do know that this audience is a pretty technical audience. So one of the things that could be interesting for this audience is to know like what's happening behind the scenes. What is Lutra doing here that's making this work? So whenever Lutra is running, we are doing a agentic operation that actually runs through software. So Lutra actually generates code behind the scenes to do this task. So this is all code Lutra generates with prompts, with different details in there, and then it's able to run and execute that code to achieve its goals. So if you guys are familiar with systems like Kodak or Small Agents, I know has a part of this as well. We are working down that path where we're making it very code oriented as well. So over here we see the second worksheet being created by Lutra, and you can see date, guest names, company, email subjects, and these things are to fill in here. So it's one of these things we can now. These are all test emails, by the way. So sample names. So if I went here and click on like this email in the Gmail inbox, you can see Sarah Murray, UCSF Health, and this is pulling it out exactly from the emails itself, right? Making it really easy to work with. So one thing that we have noticed is that in organizations, it's often not just about getting work done faster, but the bigger goal is to automate something, right? So if you are automating something in your organization, Lutra could be an interesting solution because we can now quickly go from a conversation like this into a reusable playbook that anyone can use, right? So in this case, I'm asking Lutra to take that conversation, that process that we just did, and say, could you make it into something that I can run again on a regular basis, or run it with different inputs, and create that reusable workflow for me? Right? I'm able to see what Lutra has decided I can change. I can see what Lutra's plan is, and then after that, I can say create a playbook, and it will then now add this knowledge of a process into the AI's memory. Right? I think this is also a kind of important concept in here, in which a lot of times AI comes to us, it is really just raw intelligence without any understanding about the processes our company wants to use or a business wants to use. So figuring out how to imbue the AI with the process memory, procedural memory is really important. And so this is done. Now we can see review this, and then now this is a process that anyone can run on a scheduled basis automatically, right? And so this is Lutra in a nutshell. So if you're in a company looking at agentic automation systems, this is an interesting platform to consider, because we also allow our users to bring in custom integrations into Lutra so that you can get all of the chat conversational interfaces out of the box working for you. And you don't have to worry about figuring those pieces out in there. Okay. I'm going to switch back to my slides in here. Let me do that. Mhm. Cool. So that was Lutra in a nutshell. So what we're doing is really the concept, what I call the concept of zero code AI automation, right? And traditional automation and traditional tools, a lot of them still require us as the end user of it to need to go in there, change things up, click, drag and drop. And then when automation fails, when things fail and this big diagram stops working, it's really challenging to debug and fix that. So one of the things that's really nice about AI was that when AI becomes the central component that does all of the pieces for you, designs, runs, and debugs it, we become more free, right? So what we have seen from user feedback so far is that your day changes. It's not just that AI automates for you; it's that you can shift your time from the work that was very repetitive, rote, and mundane to doing things that are way more high valued in a day-to-day basis. And that, I think, is a big shift that's coming. And I think that's a shift that all of us in this community are super excited about enabling. Cool. In fact, I think that might be all I have for things. I'm not sure if people on the stream have any questions or anything that you'd like to bounce ideas on, and I'm happy to chat. Yeah.
Yeah, I think Lutra is an amazing product. I just wanted to share like how I've personally been using Lutra. So there's kind of like two things that I tried to use Lutra for that, it was able to do that like ChatGPT like really couldn't do. And you can just imagine like if Jaquan and his team built like an amazing product and they kept going, like how amazing the technology could be. So the first thing I was actually trying to do is we're going to be launching this item essentially sometime soon called like the Armor Institute. And the idea of the Armor Institute is we want to have all these different events in different locations. And to kind of do that across the USA in a way that's like really scalable. So with Lutra, I was able to just search in hey, I'm looking to host AI events in location Boston and location DC and location Los Angeles. And what was really cool is I was able to search the web, extract all this information, put in a spreadsheet, let me update the spreadsheet in real time, and get both venues, speakers, and as much information I can to help me automate a process that would have otherwise took me weeks, right? So very, very cool. And the second kind of use case is as I was preparing for this AI Day Summit, we have a lot of speakers that are all amazing, and all of them deserve really amazing introductions. So I use Lutra to really quickly go through the web and actually help craft really amazing introductions to help introduce the speakers. Two things that otherwise would have just taken me so much time. So thank you, Jikwan.
No, and thanks, Nathan, for using our platform, because send us all feedback. And I think you hit the nail on the head, right? Which is these some of these tasks, we know how to do it, we know how to tell the AI how to do it, but the hard part is can the AI compose and orchestrate across all its actions, all its tools to do it, right? And I think with Lutra, we're taking a particular approach to it that is very code oriented, and super excited to see what the community builds. And yeah, if any of you are interested to chat more and be in touch, we'd love to connect. Yeah.
Awesome. Thanks so much, Ikon. Thank you. So that was an amazing presentation by Jikwan. I really appreciate it. Excited to see what he continues to do with Lutra. Next up, we actually have a really great friend of mine, someone I've known from the early days when we were both interested in programmatic labeling. My friend Amrutha.
Hi, great to be here, and thank you for inviting me, Natan. We've both come such a long way since we met over 2 years ago, and I'm really excited to showcase some of the new things that we're building with Structured. So happy to share my screen and dive into what we're doing. Just let me know if you can see this. Can you see this?
I personally cannot.
Let me try again. What about now?
Yeah, I can see it.
Awesome. Perfect. So I can first give a little bit of a high-level introduction on what we're doing and why, and then show a live demo. So at Structured, we're working on making it very, very easy for people to build and deploy analytics dashboards entirely in Python with our open source library, Preswald. So the trend that we saw happening in the world is, people want to build things in code, in a world where ChatGPT can generate Python with just a simple prompt, going and using kind of clunky no-code tools is no longer relevant. So we built Preswald, which is a simple way to not only build visualizations, but also be able to deploy them into web apps that you can then share and customize the layout, the branding, and more. So before I can just maybe go into a live demo. So this is our structured studio here. So this is where you can create a new dashboarding project. So when you log in or open up Studio, you can actually select a folder, create a new folder. I can go into one that I started earlier. And this allows you to do a few things. It allows you to make data connections. So you can add in CSVs, you can add in Postgres tables, really anything like that. And you can quickly at a glance be able to preview what's actually in this table, what do the data items look like. And we make it really easy to customize branding. So you can update a logo. So here I can just upload a logo and set the color and really be able to create an asset that looks relevant for my project. And here this you can see here is entirely Python code for generating your dashboard. And when And, like you can customize it. So if you want to slice and dice the data differently, you can edit it easily here. But you can see that it's very easy to get that feedback loop between the data, the schema, the metadata, and the code generation, and be able to like get like a really nice asset that you can then like deploy and share. So if you then want to, like, let's say, send this to someone on your team, you can just hit share. And that's going to take like a little bit of time there. I haven't configured it for this project, but the idea is like this is actually going to spin up like a URL for you that you can then add authentication to and be able to easily send to your teammates. That's like all I have for now on here. We're working on some new projects so where you can actually like have like more like natural language like drafting and like use this as like input as you're generating code here, and like working on a lot of really cool things. But yeah, really like what we're building is like really democratizing analytics with AI and enabling better code generation. So all of the examples that you saw here today are available on our GitHub. So if you want to, follow along or try building your own dashboard, you're welcome to just scan this QR code and drop us a star if you like what you see. And I'm happy to connect outside of this as well. So this is my LinkedIn. But that's all I have for you today. And just hoping the rest of the time will be for answering questions.
Yeah. Well, let's first say everyone should like pip install Presswalls, right?
Yes.
Yeah, thanks so much, Amrita. I'm kind of curious about you, like personally, from your like startup journey. You kind of come so far from like where things kind of went out. I was wondering if you can kind of maybe share some details on like what you're building now, Presswall, and how you kind of got to that point.
Yeah, for sure. So I think like with a lot of startup ideas, I think it always takes a lot of iteration to figure out like what is actually going to solve like a problem for a real person. So we were always very, very passionate about like making data more accessible to other people, making analytics more accessible to other people. And when we first started exploring this idea, we saw like how often like the non-technical personas within an organization would have to wait to like get answers to like problems that they were trying to solve. And I think like for us when we saw like the power of like code generation, we just felt like it was like a really powerful way to like up level like a lot of people on in an organization that want to be able to do things self-serve into the data more. And I think like we tried several different things. Like we first started off building like a no-code platform, and I think we quickly realized that like it was not as powerful. So there was always this trade-off between power and ease of use, and we just wanted to build something that could be both. And that led to like a series of figuring out how to slice this problem and figure out the right like form factor for building this. And so I think being able to also go open source, this was like a very exciting opportunity for us because with any data related product, being able to try it with your own data without having to upload it to another service is like extremely powerful. So that was also something that we like learned from our customers and users. And so I think like long story short, with anything like with any startup, always like be able to adapt based on the feedback that you're hearing from the people you want to build for.
Very, very cool. Very, very cool. It's also cool, I feel like, for Presswall too, because as someone who's like in the data space and like a data scientist, you're kind of building something I feel like that's like you would kind of use, and I'm just really excited to see where it goes.
Yeah, absolutely. Well, thank you so much again for having me. And like if again, like if this was interesting to anyone here, like please like shoot me a message after the call, and I'm happy to get you set up.
Awesome.
All right.
Well, thanks so much, Amrutha, for another incredible talk. Amrutha actually was at our first AI day out of New York, I think last year, and now it's kind of crazy to see how far she's come with Structured, and we wish her all the best and hope to be really strong design partners for years to come, and friends, more importantly. So I'm going to share this QR code again in case anyone wants to join our Slack channel. Yeah, see that? Join. Yeah, we're trying to build a community to help make AI more accessible and bridge the gap between the tremendous potential of AI and the everyday tasks that people care about. We're just really grateful for, the community's continued support. We do have a little bit of time today, so I do want to just share really quickly more information about our in-person event tonight at CIBC. So essentially at, now we're getting some scans, so I'll put this back up. Essentially tonight at 5:15 p.m., we're hosting an event at CIBC in New York. It's pretty action-packed, so we apologize if there's any lines. But yeah, we'll be launching a few really amazing products focused on community building and AI accessibility and open source. So thank you. I guess without further ado, I'm going to put on some cool theme music. Try to guess the theme. Thank you, everybody. We've got a lot of QR code scans. We will officially have a larger Slack channel than Sageflow. Hey, how are you doing today?
I'm doing well. How are you?
Doing well. Long time no see. Yeah, well, Juraya is a friend of mine and also the co-founder of a low-code AI agent company that's building, in my opinion, one of the best low-code agentic platforms for actual real-world complex agentic AI tasks. without further ado, I'll let Jeremiah take it away.
Awesome. Thank you so much, guys. I'm really excited to be here. As he mentioned, we're both friends, so I'm very excited to be here and support this conference today. So I'm one of the founders of SageFlow. I also have another founder, CTO, who could not be here today, but I'm going to take it off. I'm going to keep this presentation very simple. And we're just going to talk about what SageFlow is today. How do you build basic, like very basic agents? What are the frameworks? What are some use cases we're seeing at SageFlow? And lastly, like how are we differentiating ourselves from other competitors in the market? So as I mentioned, we're SageFlow. So basically, I'm assuming a lot of you here are really familiar with building agents. So what is SageFlow? SageFlow is a platform that allows anybody to build, deploy, integrate, and evaluate agents, all without coding. And you could go onto our platform today and actually just sign up. So like you'll get early access to our beta when it's get launched. Again, the focus is on non-technical users and citizen developers. So if any of y'all are here that are non-developers or citizen developers, feel free to sign up today, and we'd love to see use cases from you guys. So how are we like actually different? I would say we are programming first, which I know is a conundrum since we said with no code. We do have a programming first approach, is a visual syntax approach, where we give complete control and transparency of what your agent is doing in real time. We're also backward compatible with workflow builders and prompt wrappers, meaning there's a lot of prompt wrappers out there and workflow builders that are not completely agentic, and we're compatible with them, but also we're a step further ahead of them. And autonomy can also vary and on our platform because the use cases vary for each user and business. So autonomy on how much autonomy each agent has can vary. And memory capabilities are also going to be implemented. We're very excited to be pioneering really niche memory store frameworks for our agents, which actually, in my opinion, lower compute costs and token usage for our users like you. So again, I'm sure you guys are familiar with what is an agent, but for those of you that are not, this is how I would say that an agent is. Again, there's a lot of definitions floating around of what an agent is. If you look at this chart from Hugging Face, look at all these agency levels for an agent, right? And these are all these different things that are called. There's a multi-agent, there's a multi-step agent, there's a tool call, there's a router. And if you go down just the rabbit hole, what an agent is, everybody has a different definition. But what I think true agents are, they're actually prioritize adaptability, decision-making, and autonomy. And they enabling them to effectively handle like complex tasks and open-ended tasks. And how I differentiate an agent is, how do you define what a task could be an agent? If there's a task where you need to be adaptable, it's not rigid, where you need a lot of decision-making, then it could be qualified for an agent. But if it's like a deterministic task where it's predetermined and you're like, it's the same workflow over and over again, it's linear maybe, then I actually don't think you need to build an agent for that. So before you even go down the rabbit hole of building agents, please categorize if your task is actually agent worthy. Like, do you actually need to build an agent for that? Just because it's a buzz term and it's sexy nowadays does not mean every task needs to be an agent. So think of an agent as having two main parts. The brain, which is like the AI model, and the body, which is the capabilities and tools. The AI model or the brain actually handles the reasoning and planning. It then decides which actions to take based on the situation. Again, in our platform, we want to plug in under the hood the best models out there. We're looking to integrate Llama, Meta, Gemini, Mistral, and obviously more recently DeepSeek. So you actually get to decide like which model do you want to plug in when you're building agents. And again, the model you decide is actually up to you as a user. We will provide you those options and you can decide on your end which model do you want to use. Or in cases where you're not like familiar with models, we can make that decision for you if you choose to go down that route. The body, the capabilities and tools. This part represents everything an agent is equipped to do. The scope of possibilities depends on what the action the agent has been equipped with. So when people come to me and they're like, I want to build an agent, I ask them, what is the task that you want to automate? And what will the agent actually do? Like, what are the scope of possibilities that the agent needs to handle? What action will the agent be performing? What action will be equipped with? You need to determine and architect that before you even go down the rabbit hole of building an agent. So that's very, very important. You can't just get up one day. I know like Lovable and Bolt, all these no code agents are like, you just go in, you put in a prompt and it spits out. Okay, that's cool, but agentic workflows are very different. You have to architect the workflow before you even go on the platform. Think about what is it being used for. Think about whether it's useful at all. If the cost is actually worth building that agent. And in summary, an agent is simply a system that uses an AI model to do the steps below. Understand the natural language. It needs to interpret human instructions in a meaningful way. Secondly, it analyzes the information, makes that decision autonomously, and devises strategy to solve problems. Now, one thing I need to like actually define here is that you need to have guardrails in place. Like, would I actually tell an agent to go pay my credit card bill every month? Only if I have guardrails in place. Like, so think of scenarios where an agent could go off the rail. That's why it's very critical to really have those guardrails in place and, you know, have that architecture in place in a meaningful way. And lastly, agents are able to interact with this environment, gather that information, and take actions. And one thing I want to note is obviously most of you have probably heard about Operator, which is a web search agent where it browses the web. OpenAI released it. Well, I think agents are going to go beyond just the web. And I think that's something that we're working on the back end in our platform. And I'm very excited to present that later on, where we think that agents are not only to become multimodal, like beyond just text and go into voice, but we also think they're going to be multi-platform. So basically, what are the building blocks of agents? You obviously choose the right LLM. Want to go with Mistral, want to go with DeepSeek, you decide. Define the agent's control logic. Very, very critical here. Define the core infrastructure and features. And again, the agent you build is dependent on these tasks. Like if you're building an agent to automate Reddit sentiment analysis, so you could probably like do better SEO on Reddit. That's going to be very different than if you're building a voice AI agent for trucking company, right? Very different control logic, very different infrastructure. Define the agent's key roles and tasks. So think of like you as the manager, the human in the loop is the manager, and you have to give the task and role to that agent. Just like how a manager would assign that task and role to a human assistant or digital or analyst, for example. You also have to handle the raw LLM outputs. Very, very critical on how you interpret that output, evaluate and tweak as needed. And this I cannot emphasize enough. So many AI agent building or development platforms out there that are no code are skipping this last thing. Like eval, I think is the most critical part of the agentic world. Like, why are you not going to have eval in place? Like, the only reason you're building an agent is to evaluate if you actually is worth it or not. So having those benchmarks in place, evaluating that agent is critical in my opinion. And I think that's like the missing component a lot of our competitors have right now. Eval is not being taken into consideration as much. So where do we think that like the agentic industry is going? So it's a very interesting conversation. I think me, Natan, a lot of the other builders in the community probably think about this every day. Like, where is the world headed? And I actually think that agents will eventually replace traditional software and SaaS companies. I know, but I actually think the reason why is because agents are actually more proactive. They learn and act autonomously. They use natural language. They adapt to your needs. They're also not just web-based applications. They're like your mini digital assistants. Now imagine like having an army of digital workers for you, except they're not human. How powerful would that be? And that's where I think the world is going. And that's why you're starting to see pushback in the SaaS world in terms of pricing. Like, how would this impact larger software industry? Well, one thing I can think of is that if you have agents replacing software, the prices for software, the price for product development will also start pummeling. And that's actually a good thing for builders like us and builders like you out there. Agents are also your digital assistants. They will personalize, they will be adaptive. Natural language will be the primary interface. Imagine talking to your devices and having them understand you. Like I said, like if you had an agent and you're talking to it, right? Like beyond just Siri, but it then actually acts on your intentions. Like I see that happening with every integration out there in iOS shortcuts, in Siri, in Discord. Imagine having agents working on your behalf on your phone on the go. Because think about it, right now, agents are relegated to just the web-based world, right? You're relegated to these APIs, integrations that are like on the web. But I actually think agents are going to be multi-platform. I think they're going to go beyond the web 5 years from now, I personally think millions of consumers are going to have agents in their hands on the phone. They will also affect all software categories globally, which is why I think the biggest labor shift is happening right now, where knowledge workers are going to be impacted a lot because pricing for shipping these products is going to fall. In return, that's going to affect how we price labor in the market. We're actually going to shift the focus from operating systems to orchestration. So think of your traditional OSs out there. I don't think they're going to be as relevant anymore. And there's going to be new platforms out there, new OSs out there that will actually manage these intelligent agents. And LLMs are driving these changes under the hood. Obviously, all these agentic platforms are built on top of model layers. But as the prices for these models fall and the context windows get better, this will also impact how agents are deployed and how much pricing will fall. And again, this is good for you and I, guys, because as compute costs go down, the model app costs go down, deploying agents will also become cheaper. So what are some agents in the wild right now, which people call them agents? I don't call these things agents actually, but these are what actually is in the market right now, where some platforms that are considered no code might call themselves agent builders, but they're actually not agentic platforms. They're prompt wrappers, meaning they're just a wrapper around an LLM, just like on OpenAI or whatever. They're workflow builders. They generally have some predefined flow. N8N is a very good example of a workflow builder. And, as I mentioned earlier, not every task needs to be agentic. You can actually just go to N8N, and if you have a linear workflow, you can just use that. Black boxes, these are just like agentic platforms where like you don't know what the hell's going on. Like one example is Crew AI, and then programming first. These are agentic platforms or like frameworks. And for example, LangChain is an example of a agentic framework where it's like developer focused. You need to know how to use Python. AutoGen is another example. Hugging Face came out with their own example. These are agentic frameworks, meaning they're the building blocks of a framework where you can actually use that framework to build agents, but they're extremely coding heavy. You need to be a developer to be able to use them. So that comes to us. I'm like ranting for the past 20 minutes. How is SageFlow different? I like to say we're democratizing access to AI agent development. I'm building this platform for only one reason. I am not a coder. My CTO is, but I'm not. And when I was trying to build agents the last 12 months in 2024, I ran into a ton of issues with the LLM wrappers out there or the workflow builders. Either they're so simple that they actually cannot perform the task, or they're extremely complicated and technical like Crew AI. So we prioritize our focus on non-technical users. Why? Because there's only 30 million developers, but billions of non-technical people out there. And we think majority of adoption is going to happen by citizen developers and non-technical users. We also prioritize hybrid human AI feedback. I actually don't think there's going to be a world, at least in the immediate term, where like agents are just going to be out in the wild and doing everything. You still need humans in the feedback loop, and humans are still in charge. Like agents cannot completely replace humans in the chain. They're still needed for the feedback loop. What we really, really are happy about is our focus on everyday integrations. Think Siri, Discord, mobile, and iOS shortcuts. And lastly, we're visual programming based and also have better modularity, which means agent development becomes like way more flexible and scalable on our platform. So these are the core differentiating factors that actually separates us from our competitors in the market. So what are some like really, really cool use cases we've seen? The past few months, we've been in customer discovery. I've had dozens and dozens of calls with consumers like you and I, and also with businesses. These are the like really, really cool examples I've seen in the last 2 weeks. Reddit and Twitter sentiment analysis. So we had a marketing analyst come to us and tell us they want to build an agent where we integrate the Twitter API. It can actually like find keywords, use the keywords off of Twitter for their ICP. Then it uses those keywords to create like headlines and content. Then it optimizes long tail keywords based on that data, and it spits out like actually like amazing content for their ICP. And that's all through 2 agents that you can do. Another example we've seen is automating research and scoring on startups for investor meetings. So I'm actually going through a fundraise myself right now, but I had this VC analyst coming to me like 2 weeks ago, and they're like, I want to use an agent where like I want an agent to automate all the research on all the startups in the B2B, like, I don't know, femtech space. And they want to like an agent to actually research those companies, find those companies, research those companies, score those companies, and then like rank the top scoring companies, and then they will go and present that to their like GP. And I always thought was like that was wild. I come from the IB world, and I like if this was available back then, I would have used it. Automating obituary data retrieval for a funeral company. This was the most morbid example, honestly. But what this means is that like there's use cases in industries we've never even thought about. This was a funeral home company that wants to use agents and perform RAG on their data and then like spit out obituaries for people that are deceased. And it's a really large funeral company, and they want to implement these agents in their workflows. Why have they come to us? One reason: Salesforce is charging them $400,000. Can you imagine a small business that's merely making $500,000 to $1 million and giving 400 grand to Mark Benioff every year? Well, that's why I think platforms like ours comes in. We're actually going to be able to offer the solution at like 1/100th of a cost to these businesses. And we have a leg up in this space. Lastly, I thought this was a very cool use case. We had a guy who has a trucking company who wants to use agents, voice AI agents specifically, to automate customer support for his truck drivers. So if you're a truck driver going cross country and your truck breaks down in the middle of the night, you need to contact a customer support agent. And then the customer support agent, depending on whether they're awake or not, they like would call a workshop. Well, this guy is like, well, I want to automate, get rid of the human in the middle. And we build a voice AI agent so that truck drivers are able to communicate with that voice AI agent, and that voice AI agent is able to gather that information and give it the next steps or contact the nearest workshop to get their truck fixed or whatever. And this was a multimodal use case, right? It's implementing voice. And the possibilities for agents are endless. This is just like the first or second year in this space. And as we get better, the compute costs go down, as our infrastructure becomes better, as data privacy concerns become better, as we become better on like on-prem solutions for enterprises, I think these solutions will become better and better. And the use cases again are endless. I think the problem right now in the industry is that education is lacking for users in general. Like they don't know how to differentiate between a workflow versus a simple like API call to an LLM versus an agent. And these things are very separate. So the first thing I tell people is if you're going to implement an AI agent strategy in your business, actually define what is it for, what's in it cost you, and is actually useful for you. And if it can be done without an agent, go do it. Thank you so much. This was SageFlow. Loved being here. I just want to plug our community. I know our host today has an amazing community. We also have an amazing community. If you go on our QR code, you can scan the QR code. It will actually take you directly to our website to sign up. Again, our beta access is going to be available for our initial users very, very soon. So be the first ones to get access to this product. We're also taking calls with people that want to build their agents. So if you're a business or you're a consumer and you're like, I just want to chat with somebody for 15, 20 minutes, these calls are completely free. I'll be able to hop on a call with you, understand your use case, or even just like educate you on the topic and just like learn what the pain points are for you in your work or day-to-day life in your business or your professional or your personal.
Thanks so much, Juariah. This is an amazing talk. Honestly, like what you're building is so important. Like there's so many people that could benefit from having and using agents, and all the workflows people want to do is really complex, and most people can't code. So if like you end up building this, I'll definitely will try it out and share with a bunch of my friends. And yeah, everyone kind of join Juariah's community as well. And thank you so much for your time, and it's cool learning about the use cases. So.
Thank you so much. Bye-bye, guys.
Amazing talk by Juariah. Everyone go and check out SageFlow. Next up, we have my old roommate and a great friend of mine, Bernardo Aceituno.
Thank you, Nathan. Thank you for inviting to the presentation. It's a pleasure to join today. Instead of giving a set of slides today, I wanted to share a little bit about our project, Stack AI, and what we've been doing over the past few years. Fun fact, Nathan and I were roommates back on my days at MIT when I was a PhD student, and Nathan was, exploring his early days as a developer in Boston. So yeah, so since then, a lot of things have happened. My name is Bernard. I'm the co-founder of Stack AI. At Stack AI, we have developed a platform that allows enterprises to design AI agents using a visual programming interface in a way that is very flexible but powerful, and design in a way that you can deploy enterprise-wide. For instance, banks, hospitals, private and hedge funds use Stack AI to generate a set of internal tools that use AI agents to automate back office processes, such as training staff, processing documents, performing deep web research, and enriching internally database information. I think that the best way to run this conversation is probably to do a quick demo of the product and go together into building what would be a common use case for AI that we could use. For instance, enriching a data set of customers attendance to a conference by doing some research on it. When you come to Stack AI and you have an account, an organization will have a dashboard where they can organize all the different agents that they have created for different common internal use cases. And here I'm actually showing you my organization, where I have a few agents I have created before for me before. A Confluence assistant that helps me find resources in our an internal Confluence, an RFP response agent that helps me find responses to our draft responses to RFPs, a conference scraper that scrapes the attendance to our conference, and some legal workflows to like manage invoices and whatnot. The way Stack AI works is that whenever you want to create an agent for a process, you have a workflow builder, which is a no-code interface, where you can design the logic for your workflow by dragging and dropping and connecting blocks together in order to connect an interface, or using a quick start that could very quickly give you a powerful AI agent that can connect to the internal tools and knowledge bases. Let's start from scratch and see how we can build something together. For the purpose of this demo, we're gonna build together an AI assistant that will help me research leads that come to our platform and will help me answer key questions about them, like who they are, how big is their company, what's the opportunity, and based on our use cases or what we do in a company, how they could use our product. As you can see, we give you a wide variety of templates to get started for common use cases like performing web research, having a Q&A agent to interact with a database, analyze contracts, respond to RFPs, draft investment memos automatically, and the likes. So for this purpose, we're going to start from scratch. We're going to start with an empty project. And we're going to be defining what do we want our AI agent to do. This screen here you're seeing is the main screen of Stack AI, is the workflow builder. It's the place where you will design the logic of your agent. Meaning, what are the inputs of my agent? What does the agent receive from the user? What are the outputs of the agent? What do I expect it to generate? And what logic should it follow in order to complete that task? The simplest agent you can build actually is one in which you have by default a text input, and that's the only input you have, and you connect it to a text output in your workflow. And that way you create something where you can have a message like, hello world. And by executing this agent, it will essentially just send this message from here to the output. And you could see it. Nothing very impressive. But the powerful thing is that as you want to build internal applications, you can have a wide variety of inputs. You can have text inputs, but also you can have files. You can have websites. You can have audio recordings. You can have images. And you can even trigger this workflow whenever you receive an email or whenever a certain schedule happens. For the purpose of this workflow, because we are researching companies, our input is going to be the name of the company we are researching. I say company, and here you put company name. That's going to be our input. We're going to call this input company name. For instance, I want to research a company I just signed up to my CRM called DHL. Now, what's happening next? In the output, you can also generate multiple kinds of output. By default, you generate a text output where you can have a report text, a table, whatnot. Anything that can be generated by a language model in text. You can also generate images, you can generate audio, or you can execute some actions like writing the output to a Google Sheet, writing it to a Notion, sending it an email or whatnot. So you can have also kind of like writing commands as the output to the workflow once it completes its execution. Once you have these components together set up, the next question is, okay, what happens in the middle? In the middle, you can add logic. And the first component you're going to want to add is a large language model. Why? A large language model is going to be the way in which you're going to enrich the information you have in here and submitting the output of this form. So for instance, the first thing I could do is to add a language model. Let's say I want to pick an OpenAI language model and drop it here. Because Stack AI is designed for the enterprise, we are language model agnostic. You can bring your own language models hosted in your own premises or from your own cloud providers like Azure, Bedrock, or even Grok or Cerebras. You can even bring your own language models hosted locally if you decide to use Stack AI on premises, like many of our customers do. So for instance, a very common workflow I would do would be one in which I take the input I have in here, let's say this company name, I pass it to my language model as an input, and then whatever it generates, I send it to the output. Of course, I need to tell the language model a few things. First of all, what model do I want to use in order to power this workflow? I could use, for instance, GPT-4o or O3 Mini, which is the latest model from OpenAI, in order to perform this task. I also need to give you a list of play of natural language instructions telling what is this task. I can tell it, you are an assistant that helps me research companies and extract the following things. And what would be the kind of things I would like to extract? I would want to extract the company name. I would like to extract the employee size. I would like to extract the approximate revenue per year. I would like to extract potential use cases for language models. And I would like to extract what similar clients do we serve. Now, this is a complicated task because it involves that the language model should be able to somehow find all this information from both public sources, but also private sources, like what clients do we have and how they look like. And that will be the set of the way in which we are constructed to work. In a section called the prompt, I basically tell the language model what the inputs it can have on the live hour. And in this case, it only has one input, but it could have many. If, for instance, I provided alongside with the company a file, let's say a set of documents, I could perform OCR on these documents, extract the text on it, and pass it to the language model as an input, and it could have another one. So in order to handle those scenarios where you can have multiple inputs, in a section called the prompt, you can specify what each of the things connected to the language model are in plain English. For instance, here I'm telling it by default the user message company name. And here I'm just gonna tell it company name is gonna be whatever comes from this text box, company name. It's like company name to research, company to research. And based on that, I'm gonna get the response. I could give it additional instructions like respond in bullet points, and that way get a more structured response in the end. Something I didn't mention is that these language models also allow you to provide them with tools, meaning ways in which they can actually interact with external APIs in order to complete their tasks as they're performing a response. They can do web search, news search, they can search on LinkedIn, they can send an email, they can create tickets on Zendesk, they can do research on Yahoo Finance, they can send refunds, they can do operations on Stripe. And this way you can build quite powerful agents that can be done for customers, can be used for customer success, internal support tickets, IT service desk, or whatnot. Something I could do in here is I could give it some Yahoo Finance analytics in order to research this company. In the case that there's a ticker that we know. So first, if I run this workflow now with DHL, it's going to take the text, it's going to pass it to a language model. This language model will follow these instructions, knowing that this is the input it has, and evaluating the tools I have given it to it. And with that, it will reason, being O3 Mini, a way in which it could use this tool to complete this task, and then generate a response. For instance, in this case, it gave me a relatively good response of what we have. For instance, in here it's telling me the name of the company, it's telling me the size, approximately the revenue based on annual reports that it found on Yahoo Finance, potential use cases for LMs, and common clients, similar clients. Now, maybe I find that this is not enough information. Why? Because it doesn't have any context on my company. For this purpose, there's an entire new section within Stack AI that you can take that we can look at, which is the knowledge bases. Knowledge bases are a way in which we can inject knowledge in the language model from either private sources of knowledge, like our internal documents, let's say our Google Drive, our SharePoint, our Confluence, in order for it to be able to reference these sources when it gets a response to the research on this, or public sources online, like LinkedIn, Google search, web search, in the future, very soon also PitchBook, in order to add information from these sources live to the language model. For instance, I could add information from LinkedIn to give them context on what this company is, what has been found for this company on LinkedIn, and in our internal knowledge base. For instance, I can add a knowledge base of documents where I can put the list of customers that we have and their use cases. For instance, I have, just by nature of by coincidence, a table where I list some of the use cases and customers that we have at Stack AI. So I could use that as a source for the language model, in order for the language model to know what are the use cases it can cover and what customers do we have by industries and departments. So for instance, now I could build a workflow where, based on this company, I search this company on LinkedIn, I search the closest thing to this company inside of our knowledge base, and I pass these three components to a language model: the company name, the results of LinkedIn, and the results of our knowledge base. And with that, we have a workflow that where I can tell the language model company to research, I can tell it context from LinkedIn, I can tell it context from our knowledge base, And this way, actually have a workflow that now is completing a deep research in LinkedIn, our internal documents, and the source. And in this case, I uploaded just one table of files, but I could upload an entire library of thousands of SharePoint documents or thousands of files from my Google Drive and have these be sources to a language model. I could also connect it to our databases. Let's say if I have a database in Snowflake of common use cases and deals, or a library on Postgres or any common other source like Airtable, even in our own Slack or CRM like Salesforce or HubSpot. If I now run this workflow, you'll see I now will run a much more complex process. It will take this company name. It will first research the company on LinkedIn. In parallel, as it's researching the company in an internal database, as it's listening, it's scraping the websites, it's handing everything to the language model. With this context, the language model will now take all these pieces of information, will reason how we can use the tool I just provided from Yahoo Finance, and based on these instructions, completes the that I gave it. Gave me the company name, employee size, approximate revenue per year, potential use cases of LLMs, similar kinds of serve, and give me a response in bullet points. And write me that as I ask it for in format. And it will tell me actually from each source where I got everything. Company size, approximate revenue per year, potential use cases for LLMs, based in our actual table of use cases that we support, and similar clients that we have supported. For instance, here specify some of our clients similar to them, Nubank, HNTV, that we have actually worked with in the past. And in this context, it will generate this. But what if I want more? What if I actually want to take this and automatically serve it to Google Sheets when I finish it? Well, something I could do is I could tell it, give me, instead of a table, give me a JSON. Don't give me citations because I don't need that. And let's use a model that is a bit faster, like GPT-4o. And let me tell it, instead of responding in bullet points, respond in a JSON with these fields as keys. And then, apart from getting this output, I can also in parallel take the JSON generated and add it as a row to my Google Sheets, where I can connect to my account in Google Sheets. I can just test one of my connections, set that up, pick a sheet I have created, add as the spreadsheet ID, and then save it in order to upload it there. I don't know if I had too much time that time, but I could show you very quickly how this could work. And with that, demonstrate kind of like how this can go full loop into building an entire AI workflow agent that can power an application in a production-ready application. For instance, I just created a Google Sheet in here. I'm putting the spreadsheet ID connected to my Google Drive account, of course. And I'm putting in here the ID of the sheet I have to connect to. So now if I run this workflow, which I can zoom out, I can then go, connect to it, run it, and do its process. And of course, this interface is very friendly and simple, but it can also be powerful. Some other things I could touch on are the ability you can use to use logic like Python, like calling Python in the middle, add routing logic to pick different paths, add your own custom APIs in the middle, or so, allowing developers and more advanced teams to add multiple use cases in the middle. So for instance, now you can see that my language model generated a JSON. If I go to my Google Sheets, you will see that now this actually added an entire new sheet to my Google Sheet with all the components I needed. So that if I do add all this information in the future to my Google, if I want to research 100 companies in the future, I can do so. Now, going back to this workflow, this interface is very nice, but how do I make this useful for my business users? Naturally, we don't want business users, people in my sales team or people in my marketing team, to be interacting with this complex workflow. For that purpose, developers in here, designers of this workflow, can save them and publish this in order to create an application where they can use one of our many pre-built user interfaces in order to share them. By default, we offer them interfaces such as the form, which basically allow you to specify different inputs you have and get an output in the end. A chat interface, in which case you can have a ChatGPT interface where you can interact with this agent, or an API, so that you can actually call this agent as part of another downstream process, as well as a batch interface, so that you can call this workflow many times in parallel, in the case that you want to, let's say, analyze 300 companies in parallel from a CSV that you have collected. Essentially, Stack AI enables any organization to build a suite of internal tools that are enterprise-ready, that connect to language models and can automate a wide variety of these processes. And today, since launching, we serve more than 200 enterprises in the US and worldwide. Stack AI is SOC 2 compliant, HIPAA compliant. We serve banks, defense contractors, hospitals, many construction and logistics companies, and by nature of that, have worked with some of the biggest companies in the world. So it's been an exciting time to keep it growing, and it's an exciting time to keep exploring how we can expand. Of course, there is much more you can do than just researching clients. As you can see here, there's a large variety of agents you can build, including the ability to quickly build conversational agents that can look into a knowledge base and essentially just look for resources on them. But with that, I'm going to end my conversation. And if you want to try more or you want to look for opportunities, come visit stackai.com or feel free to reach out to us at enterprise@stack-ai.com. Thank you.
Thanks so much, Bernardo. Honestly, like an incredible talk. So let me just like reiterate everything so I like understand like exactly what you're saying. So if I understand kind of like the premise of Stack AI, it's like, hey, you know, these large language models are really powerful and people might have their own data or workflows that they'd want to do. And Stack AI kind of provides like this low code interface where you can like leverage these LMs, interact with your data to kind of build your custom workflows and tasks similar to like how like agents would, you know?
Precisely, Nathan. And yeah, and you know, you can try it today. Actually, you know, there's a free playground you can use to create an account, build some simple workflows yourself, and you know, start bringing the power of AI agents to your day to day.
Amazing. I definitely will try it out, and just wanted to kind of thank you for taking the time to join today. You know.
Absolutely. Thank you for the invite.
Wow, an incredible talk by Bernardo. You know, Stack AI, it's kind of crazy. I was Bernardo's roommate and I saw him like just kind of starting with Antony at MIT. And now it's like fast forward today, they're an incredible company and honestly, an amazing product that can help so many people. So I really hope that everyone kind of goes and checks out Stack AI. As Bernardo said, you can kind of try it out and actually build these really custom agentic AI workflows. So next up, we're still on hold for Theo. So I think I'm going to put on some cool theme music. Maybe I'll pause the recording for a few minutes to just make sure we can end the stream and restream. And then we'll be back in less than 5 minutes.